नमस्कार। आपका स्वागत है इस खास पेशकश में। और दिल की धड़कनें लगातार बढ़ रही हैं। चंद्रयान-3 की ऐतिहासिक सफलता के बाद भारतीय अंतरिक्ष अनुसंधान संस्थान इसरो अब सूर्य के अध्ययन के लिए आज आदित्य L1 मिशन लॉन्च करने जा रहा है। इसरो का ये मिशन सूर्य का गहन अध्ययन करने की दिशा में एक बड़ा कदम है। इसका काउंटडाउन शुरू हो चुका है और अब से कुछ देर बाद 11:50 पर इस मिशन को श्री हरिकोटा के सतीश धवन स्पेस सेंटर से लॉन्च किया जाएगा। आदित्ययान को PSLV C57 रॉकेट के जरिए लॉन्च किया जाना है। इसके बाद ये 4 महीने का सफर पूरा करते हुए L1 पॉइंट तक पहुंचने वाला है।
Absolutely. Thank you, Pratibim. Hello and welcome viewers to this special broadcast on Sansad TV. As my colleague rightly said, just a few days after the grand success of Chandrayaan-3, which made India only the 4th country to land on the moon and the very first to soft land on the moon's South Pole region, the country is now set to achieve another significant milestone. In just a few minutes from now, ISRO will launch the country's first space-based solar observatory, Aditya L1. Aditya L1 is a pioneering mission dedicated to studying the sun. Now, the spacecraft will be placed in a halo orbit around the Lagrange point. That's why the name L1 of the Sun-Earth system, which is approximately 1.5 million kilometers from Earth. So we'll understand all about the Lagrange point, how will the spacecraft reach there, intricate details about this mission, which is the first for India, and also what are the key mission objectives from an illustrious panel of scientists who are joining us on the broadcast today. I'm delighted to have with me in the studio Mr. Vaibhav Pant, Scientist C, Aryabhat Research Institute of Observational Sciences. He joins us in the studio, and joining us virtually is another scientist, Ms. BP Dakshayani, former Group Director, Flight Dynamics and Space Navigation Group, ISRO. She will be joining us in just a short while from now.
जी हाँ, टीना, दिल की धड़कन बढ़ रही है और चंद्रयान-3 की सफलता के बाद क्या वैज्ञानिकों पर भी किसी तरीके का दबाव होगा? वैभव पंत, आप क्या महसूस कर रहे हैं?
नहीं, बहुत खुशी महसूस कर रहे हैं। दबाव तो नहीं कहेंगे, बिकॉज इस मिशन के लिए काफ़ी पहले से तैयारियां चल रही हैं। So I think it is now more than a decade that we have been preparing for this mission. So दबाव नहीं है, but खुशी है. If successful launch होता है, then our understanding about the sun will be
So to begin with, Mr. Pant, if you could help us and our viewers understand, why is it important to study the sun now from this point? And I ask you this because we have a couple of solar observatories on the ground as well.
Yes.
So what have we achieved so far in terms of information and studying about the sun? What more are we now seeking to gain from this observatory?
Yes, so there are many observatories on ground. In fact, there are many solar observatories of sun in India from grounds. For example, there is a Kodaikanal Observatory of IEA, there is Udaipur Solar Observatory. In fact, there is a solar telescope in Aries also. So, but the main reason why we are going to space is that we can't get all information about the sun from ground. First of all, the wavelengths such as the extreme ultraviolet as well as X-rays get blocked. And if you want to study the sun in those wavelengths, you won't be able to do that from the ground. So you have to go to space. So that is one advantage of going to space. As well as if you are on ground, you can't observe sun 24/7 because we have nights. As well as there are clouds, sometimes they obscure our seeing. Even if the sky is clear, the atmosphere fluctuates over a short period of time. So your image will not be very sharp, it will be blurry. So therefore, it is important to go to space, especially at Lagrangian 1 point, where we will be able to observe the sun 24/7 continuously for many days. And that is the added advantage of going into space. So we have achieved a lot using ground-based instruments, but there are several unanswered questions that we still need to understand. For that, we have planned this Aditya L1 mission.
That's quite interesting, and our virtual guest, Ms. BP Dakshayani, is joining us now. Ms. Dakshayani, very important mission for us, and what's interesting about it is that sun is the harbinger of life on Earth, yet it remains an extremely mysterious object for all of us. So your perspective on the significance and the crucial details that we seek to get from this mission.
Yeah, you are already aware that today it is going to be launched at 11 hours 50 minutes AM from Sriharikota into an orbit of 235 km perigee, the point which is near to the Earth, and apogee around 19,500. Okay, and here for a particular day we have one more parameter called argument of perigee that will dictate the launch time now usually you have seen Chandrayaan 3 and all that within 16, 17 minutes. It is the satellite after the liftoff of the vehicle, launch vehicle, it is injected. But in this case, it nearly takes 1 hour, nearly 60 minutes it takes. Because we wanted to achieve that particular angle, we call it as argument of perigee. So that is very much required for L1 orbit insertion with minimum fuel or minimum delta V, velocity increment, whatever we are giving. So that is how. And you may be aware that even Mars mission also, Chandrayaan also, we have raised the orbit to gain the velocity. Here, this whatever L1 point is there, which is around 1.5 million kilometers from Earth, we have to escape from the Earth sphere of influence. Okay? That means we have to give a velocity which is equal to around 11.2 kilometer per second to reach the L1 point. Once we reach the L1 point, we'll reduce the velocity so that it will become an orbit around L1. Okay? And this L1, I think you already explained, between the Earth and Sun, there are 5 points called Lagrangian points. They are called equilibrium points. And out of which this L1, L2, L3, they all lying in one straight line from Earth to Sun. L1 lies in between the Earth and the Sun, and L2 towards the right side from if I view from my side, and L3 towards the left side. And why is it important to keep at L1 is L1 is a point where the gravitational attraction of the Earth and the Sun is equal enough to keep an object moving around the L1.
Right.
We need to give only minimum velocity to keep it around the orbit around the L1. So that is why we have chosen the point L1. And another advantage is whatever he has told earlier, we can observe the sun continuously 24 hours in a day, and also we can get the data onto the earth. But for the earth rotation, we can get it on instead of getting the data from our satellite through our deep space station at Bailalu. We can even get from other stations which are 180 degrees away from that, so that we can get the data more than 8 to 10 hours for our own station. We'll get the data. That is one thing. And another thing is there is no eclipse or no occultation. So there is no body in between the sun and the earth. When we place L1, neither sun can obstruct nor earth can obstruct. So there will be continuous viewing of the sun. And as he already explained, whatever we could not do on the ground, we could definitely do with all these 7 instruments which are flown on this mission.
Right.
So that we can study the sun's corona, which we have not understood. Many of the activities of the sun has not been understood. So that is why it becomes very important for us to go for L1 to study the sun.
Absolutely.
Ji.
It's the first of its kind, Pratibim, the solar mission that India is launching today. 11:50 is the time. We will, of course, be showing you live visuals as and when the launch happens. But for now, there are 2 scientists who are explaining to us intricate details about this very, very crucial mission. We're all waiting with bated breath.
लाखों करोड़ों लोगों के साथ साथ मेरे मन में भी बहुत सारा कौतूहल है, और कौतूहल लेग्रांज पॉइंट को लेकर बहुत ज़्यादा है। कौन से देश हैं वहाँ पर पहुँचने में सफल हुए, और उसी पॉइंट को क्यों आखिरकार तय किया गया है पहुँचने के लिए। एक तो मोटे तौर पर बात सामने आई है, वो ऐसा पॉइंट है जहाँ पर कोई भी चीज़ स्थिर रह सकती है, उस पर इफेक्ट वहाँ पर बहुत कम होता है सूर्य पर होने वाली गतिविधियों का। उससे आगे क्या?
ये मेन पॉइंट तो यही है कि L1 पे जो है हम सन के ऑब्जर्वेशंस जो है कंटिन्यूसली जो है 24/7 कर सकते हैं, और कोई भी एक्लिप्सेस नहीं होंगे, जिसकी वजह से हम सन को कंटिन्यूसली ऑब्जर्व कर सकते हैं। उसमें जो एक्टिविटीज़ हो रही हैं उनको कंटिन्यूसली देख सकते हैं। सो मेन पॉइंट यही है, एंड L1 इज़ लाइक अ फर्स्ट स्टेप, एंड देन हम सोच सकते हैं कि और लैग्रेंजियन पॉइंट्स में भी हम जाएं, लाइक L5 में जा सकते हैं, L2 में पहले से ही कुछ मिशंस गए हुए हैं, L1 में भी पहले US के नासा एंड ईसा के मिशंस हैं. सो बट देन इट इज़ अ प्राउड मोमेंट फॉर इंडिया कि इंडिया भी नाउ is establishing its spacecraft at L1. That is the first step, and then one can think of going to other Lagrange points.
Sure, sure.
तीनों तुम अपना कौतूहल समाप्त करने जानने के लिए बहुत सारे सवाल करो, उससे पहले खास रिपोर्ट हम लोगों ने तैयार की है. क्या कुछ है ये आदित्य L1, उससे जुड़े हुए तमाम पहलू क्या हैं, उसको बताने की कोशिश की गई है इस रिपोर्ट के जरिए. एक नज़र डाल लेते हैं इस रिपोर्ट पर पहले.
आदित्य L1 सूर्य का अध्ययन करने वाला पहला अंतरिक्ष आधारित भारतीय मिशन होगा. अंतरिक्ष यान को सूर्य पृथ्वी प्रणाली के लैग्रेंज बिंदु 1 के चारों ओर एक प्रभामंडल कक्षा में भेजा जाएगा, जो पृथ्वी से लगभग 15 लाख किलोमीटर दूर है. अंतरिक्ष यान 7 पेलोड्स लेकर जाएगा, जो फोटोस्फेयर, क्रोमोस्फेयर और सूर्य के सबसे बाहरी परत का अध्ययन करेंगे. सूर्य के अध्ययन के लिहाज से भारत का आदित्य L1 मिशन बेहद अहम है.
भविष्य के लिए कई बड़े और महत्वाकांक्षी लक्ष्य तय किए हैं. जल्द ही सूर्य के विस्तृत अध्ययन के लिए इसरो आदित्य L1 मिशन लॉन्च करने जा रहा है. इसके बाद शुक्र भी इसरो के लक्ष्यों में से एक है. गगनयान के जरिए देश अपने पहले ह्यूमन स्पेस फ्लाइट मिशन के लिए भी पूरी तैयारी के साथ जुटा है.
भारतीय अंतरिक्ष अनुसंधान संगठन ने आदित्य L1 को प्रक्षेपित किए जाने की तारीख की घोषणा 28 अगस्त को कर दी थी. आदित्य L1 को पोलर सैटेलाइट लॉन्च व्हीकल C-57 के जरिए आंध्र प्रदेश के श्रीहरिकोटा से लॉन्च किया जाएगा.
It's very important because sun plays an important role in the future of the Earth. I think Earth is all because of sun. But activities on sun is well studied today, and the solar eruptions, the solar activity do affect the outer planet atmosphere. And this has an impact on various activities or various magnetic and other related activities, electrical activities on the surface. So this requires a satellite to be placed at an unobstructed location, which is a very good place. L1, the Lagrangian point L1, which is between Earth and Moon, Earth and Sun, is found to be an excellent location. And we designed and developed few instruments, which is something like a coronagraph, which will look at the sun and study the corona over a long continuously and look at eruptions.
धरती पर जीवन सूर्य की वजह से पनपता है. अगर सूर्य की रोशनी धरती पर ना पड़े तो जीवन की उत्पत्ति संभव ही नहीं है. लेकिन हो सकता है एक समय ऐसा भी आए जब सूर्य से निकलने वाली ऊष्मा, प्लाज्मा या सौर हवाओं की तीव्रता इतनी तेज हो जाए कि पृथ्वी और इसकी कक्षा में काम कर रहे सैटेलाइट्स पर इसका बहुत बुरा असर पड़े. ऐसे में सूर्य के बारे में जानना जरूरी है अपनी धरती पर जीवन के लिए.
We also will measure the emissions which are coming towards Earth using instruments mounted on the satellite. So these two measurements will complement each other. So we can event and measurements can be correlated, which is currently not possible anywhere else. So this is the uniqueness of that measurement. And over a period of long periods of observation, we will be able to make good predictive models of the activities on sun, and so that we can quickly, suppose we observe some activity there, we know after how many years, how many days or hours this activity will have an impact on Earth as well.
इसरो लगातार कुछ नया कर रहा है. इसरो आज दुनिया की कुछ चुनिंदा स्पेस एजेंसियों में शुमार है. आदित्य L1 मिशन में इसरो के साथ कई अंतर्राष्ट्रीय महत्वपूर्ण एजेंसी भी सहयोगी की भूमिका में है.
See, we connect with European and American agencies to help us in the various mission activities. See, for example, a satellite traveling from here to L1 point, which is almost 3 times the distance of Moon from Earth. So such a long journey. When you make that long journey, the guiding it through that up to that point is very critical. So it requires many ground stations to observe it and help us to get the data. And we have to make predictive models to correct if the path is not going correctly. So this support we get from European Space Agency and American agencies.
भारतीय अंतरिक्ष एजेंसी इसरो का आदित्य L1 मिशन सूर्य का गहन अध्ययन करने की दिशा में बड़ा कदम है. इस मिशन से मिलने वाली जानकारियां हमें सूर्य की गतिविधि और पृथ्वी पर इसके प्रभावों को बेहतर ढंग से समझने में मदद कर सकती है. ये जानकारी हमें पृथ्वी के उपग्रहों और अन्य अंतरिक्ष यान की रक्षा करने में भी मदद कर सकती है.
So we'll continue to talk about the mission in greater detail, but for the moment, Ms. Dakshayani, if you could help us understand, because the report just spoke about PSLV. Now, this has been a very, very trusted horse of the ISRO. So tell us about this rocket. How are we going to take Aditya L1 to the Lagrange point, which is our final destination from where we are going to conduct greatest detailed study of the sun?
Yeah, as you told, it is a workhorse of ISRO PSLV. It has a 4-stage engine, and it will inject Aditya L1 at a point, I have already earlier told you, 235 kilometer perigee, the point which is near to the Earth, and 19,500 kilometer apogee. And I have already explained that there is a particular angle called argument of perigee. That means where the perigee is there, it is measured from one reference line, and that angle should be around 346. Okay, 346 degree. That is mainly we have to choose that particular angle so that when we go to the L1, our insertion cost, the delta V or velocity increment what we give to insert it as an orbit around L1 should be minimum. So for that, for a particular day, that particular argument of perigee will be chosen. That's why in this mission, you will see that after the liftoff, nearly for 1 hour after that only the satellite will be injected. And when it is injected, it will not inject into a velocity which will carry the Aditya L1 directly to the L1 point. So the velocity will be less than 10 km per second. But we need around 11.2 km per second velocity to escape from the Earth to reach L1, so that once we reach L1, we can insert it around the point L1, our Aditya satellite. So what we are doing is, we will give velocity increment stage by stage, and will increase the apogee of the orbit, and perigee will more or less remain same. So once we give an incremental velocity at perigee, the apogee goes into an higher altitude. That first will increase by some 30,000, then 70,000. Finally, will reach more than 1.5 kilometers. That is nearer to the L1 point. We will reach near to the L1 point. So that is, and all these maneuvers or whatever the velocity increment we give, they are called earthborne maneuvers. That we will be doing using the fuel present in the Aditya L1 mission, not with the rocket fuel. So once we do the earthborne, after some nearly 20 days, we'll do the final burn called the trans L1 injection. We'll give the velocity. Trans L1 injection insertion, it is called. Yeah, and it is around 136 meter per second or so. We'll give the velocity increment at the perigee so that it will go near to the L1 point. And once it reaches at the L1 point, we'll give a velocity of nearly some 60 meter per second to insert it around the point L1. This is the procedure we'll follow to go from Earth to the L1 point. And meanwhile, we may have to do some trajectory correction maneuver on its course, because this L1, once it escapes from the Earth, it may take more than 104 days to reach the L1 point. So we have to monitor its trajectory continuously,
Right.
and we may have to do the trajectory correction maneuver. And also we call one of the maneuver, the trajectory correction maneuver is also called as orbit shaping maneuver, that we'll do when we come near to the L1 point before the insertion. So this is how from the injection to the L1 point, our all operations will follow.
Right. So just about 30 minutes, Pratibim, left for the launch to happen for this important mission that India is now seeking to achieve success in after the grand success of the Chandrayaan 3.
जी, कंपैरिजन मैं करना चाहता हूं, तुलनात्मक दृष्टि से देखना चाहता हूं, क्योंकि भारत से पहले बहुत सारे देश चंद्रमा पर पहुंचने में सफल रहे थे, लेकिन विशेषता हमारे साथ ये रही, चंद्रयान 3 के साथ ये विशेषता रही कि वो साउथ पोल पर पहुंचा। अगर कंपैरिजन करें, बहुत सारे अभियान पहले सफल रह चुके हैं, अगर सूर्य अभियानों की बात करें तो उन अभियानों से, सफल अभियानों से हमारा आदित्य L1 अभियान किस तरीके से अलग है, या विशिष्ट है?
हाँ, तो बहुत सारे तरीक़ों से अलग है। सबसे पहला तो ये, जितने भी सूरज को स्टडी करने के लिए यान गए हैं लैग्रेंज 1 पॉइंट पे, वो सूरज को की सतह के बहुत क्लोज नहीं जा पाए, उसके बहुत क्लोज स्टडी नहीं कर पाए। सो उनका जो ऑब्जर्वेशनल फील्ड ऑफ व्यू था वो स्टार्ट होता था 2 सोलर रेडियाई से, और इन सम मिशंस इट स्टार्ट्स फ्रॉम 1.5 सोलर रेडियाई, पर इन आदित्य मिशन वी आर गोइंग वेरी क्लोज टू द सोलर सरफेस, सतह के बहुत क्लोज जाके स्टडी कर रहे हैं, और उसका जो स्टार्टिंग पॉइंट है वो है 1.05 सोलर रेडियाई। और ये खुद में एक चैलेंज है, क्योंकि जितना आप सन के सतह के क्लोज जाओगे उतना ज़्यादा स्कैटर लाइट होने की प्रोबेबिलिटी बढ़ जाती है, और उस केस में आपको टेक्नोलॉजिकल इनोवेशंस चाहिए मिरर बनाने के लिए, सो दैट ये स्कैटर लाइट कम से कम हो और अच्छे से अच्छा डाटा मिले। सो ये तो एक नया इनोवेशन है जो कि और मिशंस में नहीं था, और या सक्सेसफुल नहीं रहा। नासा में एक इंस्ट्रूमेंट था ऐसा, पर वो सक्सेसफुल नहीं रहा। सो दैट इज़ लाइक वन यूनिक थिंग। अदर जो सबसे इम्पॉर्टेंट थिंग है जो कि शायद हम कर रहे हैं मतलब पहली बार, वो है ऑन बोर्ड इंटेलिजेंस का इस्तेमाल करना। आज तक ऐसा होता था कि सन पे अगर कोई इरप्शंस हो रहे हैं, सन पे बहुत सारे एक्सप्लोजन्स होते हैं, सो उनका एक कैटलॉग बनता है कि कौन सा इरप्शन कब हुआ, किस समय पे हुआ। सो वो कैटलॉग यूजुअली जब डाटा पृथ्वी पे आता था, फिर उसको हम कंप्यूटर से एनालाइज करते हैं, तब बनता था। पर हम पहली बार आदित्य में ऑन बोर्ड इंटेलिजेंस सिस्टम को भी यूज़ करेंगे। सो अगर कुछ इस टाइप के इरप्शंस या सोलर फ्लेयर्स अगर ऑन बोर्ड होती हैं, तो वो जो है सैटेलाइट में ही डिटेक्ट हो जाएंगी। सैटेलाइट से ही डिटेक्ट कर सकते हैं, उनको ग्राउंड पे डाटा आने की ज़रूरत नहीं। सो इस टाइप की ऑन बोर्ड इंटेलिजेंस जो है पहले मिशंस में नहीं थी, और सक्सेसफुल भी नहीं रही। अगर रिसेंटली एक नासा के मिशन में थी, पर वो उतना सक्सेसफुल नहीं रहा है। मुझे बिलीव है कि हम वो कर पाएंगे जो पहले मिशंस में नहीं हुआ। तो ये दो तो बहुत यूनिक चीज़ें हैं जो कि पहले मिशंस में नहीं थी और हमारे मिशन में है।
You know, since we're talking about other solar probes, which one has managed to reach closest to the sun? Of course, it's even with this mission, even if we reach the L1 point, we'll still be closer to Earth than the sun.
Yeah. So,
but if we talk about other, and if we compare it to the other solar probes, which one has been the closest?
So the Parker Solar Probe is the closest, and it will also go closest to the sun, closest to its surface. But it has its own science objective, and we have our own science objectives. So not everything can be studied only going closer to the sun. In fact, a lot of science can be done even staying at Lagrange 1 point, and that is something that we are trying to achieve.
Right. So with each of our missions, India is trying to get something extra, something more than what the world already knows about. First it was the moon, now it's the sun. As you can see on your screen, live visuals from the ISRO headquarters in Bengaluru. Scientists all ready as the countdown begins. In just a few minutes from now, the ambitious and the pioneering Aditya L1 mission. Aditya, as you know, means the sun in Sanskrit, and that's how the name of the mission, and the L1 point, the Lagrange point, where it is headed to, so it makes the name Aditya L1. We're preparing for the launch. In a few minutes from now, the launch will happen, and as Ms. Dakshayani explained to us how we intend to reach the L1 point, it's a procedural step-by-step mission. It's going to take a little while, but we're hoping that it is going to be a success as the Chandrayaan 3 mission.
एक और बात है जिस पर हम लोग चर्चा करना चाहेंगे, पेलोड्स का जिक्र हमेशा आता है। चंद्रयान 3 की बात हुई तो पेलोड्स के बारे में बहुत सारी चीज़ें सामने आई हैं। इसमें एक नहीं, दो नहीं, बल्कि 7 पेलोड्स का इस्तेमाल किया जा रहा है। वो किस तरीके से काम करेंगे और हर एक पेलोड का क्या रोल रहने वाला है, क्या भूमिका रहने वाली है?
सो जैसा आपने बोला, इसमें 7 पेलोड्स हैं। सो मैं एक एक करके सबका एक शॉर्ट में साइंस ऑब्जेक्टिव आपको बता देता हूँ। सो पहला पेलोड है इसमें VELC, विजिबल एमिशन लाइन कोरोनोग्राफ। सो जैसा कि पहले स्पीकर्स ने बोला कि कोरोनोग्राफ इज़ लाइक क्रिएटिंग आर्टिफिशियल एक्लिप्स। सो नेचुरल एक्लिप्स में हम आर्टिफिशियली एक्लिप्स करते हैं स्पेस में। सो ये कोरोनोग्राफ जो है स्टडी करेगा कि सन का जो एटमॉस्फेयर का तापमान है वो सन के सरफेस के तापमान से क्यों ज़्यादा है। सन का सरफेस का तापमान 5000 डिग्री है, वाइल एटमॉस्फेयर का तापमान इज़ 1 मिलियन डिग्री केल्विन। सो ये तापमान क्यों इंक्रीज़ हो रहा है, इस चीज़ का हमें पता चलेगा कोरोनोग्राफ से। एज वेल एज द कोरोनोग्राफ उस चीज़ के लिए भी यूज़फुल होगा जब हम सोलर के इरप्शंस को स्टडी करेंगे, लाइक सन पे बहुत सारे बहुत इनर्जेटिक इरप्शंस होते हैं। अगर मैं आपको तुलना के तौर पे बताऊं तो एक टिपिकल सोलर फ्लेयर की एनर्जी जो है मिलियंस ऑफ न्यूक्लियर एक्सप्लोजन्स के बराबर होती है। सो एट यू कैन थिंक ऑफ लाइक एट अ टाइम मिलियंस ऑफ न्यूक्लियर और बिलियंस ऑफ न्यूक्लियर एक्सप्लोजन्स समटाइम्स हैपनिंग एट द सेम टाइम ऑन सन। सो वो क्यों होते हैं, किस लिए होते हैं, क्या हम उनको पहले से प्रेडिक्ट कर सकते हैं, वो चीज़ जो है हमें VELC एज वेल एज अनदर इंस्ट्रूमेंट का सूट, इन दोनों के डाटा से हमें समझने को मिलेंगे। हमें ये भी पता है कि सन की 11 ईयर की साइकिल होती है। इस 11 ईयर साइकिल में सन कभी कभी ज़्यादा एक्टिव होता है, कभी कभी इस टाइप के एक्सप्लोजन्स बहुत ज़्यादा होते हैं और कभी कभी बहुत कम होते हैं। और हर 11 ईयर्स में एक टाइम आता है जब एक्सप्लोजन्स बहुत ज़्यादा होंगे और एक टाइम आएगा जब एक्सप्लोजन्स बहुत कम होंगे। सो इस वजह से जो है सन की जो इरेडियंस है, जो रेडिएशन सन से आती है हमारे अर्थ पे, वो भी चेंज होती है 11 ईयर्स पे। सो ये रेडिएशन कैसे चेंज हो रही है 11 ईयर्स में, स्पेशली इन एक्सट्रीम अल्ट्रावायलेट एज वेल एज इन अल्ट्रावायलेट और नियर अल्ट्रावायलेट। सो ये भी हम जो है स्टडी कर पाएंगे। एक इंस्ट्रूमेंट है आदित्य पे जिसका नाम है सूट, उससे हम ये सब भी स्टडी कर सकते हैं और इसका इफेक्ट हमारे क्लाइमेट पे क्या पड़ेगा, क्योंकि सोलर इरेडियंस जो है हमारे क्लाइमेट पे भी क्या असर डालता है, तो ये भी हम स्टडी कर पाएंगे। तो ये दो इंपॉर्टेंट पॉइंट है। थर्ड पॉइंट ये है कि जब सन पे एक्सप्लोजन्स होते हैं तो उनसे एक्सरेज भी निकलती हैं, गामा रेज भी निकलती है, हाई एनर्जेटिक एक्सरेज निकलती हैं, जो कि बहुत नुकसानदेह हो सकती हैं। हम गगनयान भी प्लान कर रहे हैं फ्यूचर में, तो उस टाइम पे हम एस्ट्रोनॉट्स को स्पेस पे भेजेंगे। सो हमें प्रेडिक्ट करना बहुत ज़रूरी है कि एक्सरेज कब आ रही हैं, कब मतलब उनका निकलने की क्या प्रोबेबिलिटी है, कि कब हो सकती हैं। तो उसके लिए उन एक्सरेज को स्टडी करने के लिए हमने सोलेक्स एंड हीलियोस, दे आर 2 अदर इंस्ट्रूमेंट्स जिनका हम यूज़ करेंगे। एज वेल एज ये तो हो गया जो दूर से सन को देखेंगे, पर सन से जब ये इरप्शंस अर्थ की तरफ आएंगे, कुछ इरप्शंस अर्थ की तरफ आते हैं, पहले भी आए हैं और फ्यूचर में भी आएंगे। तो जब वो इरप्शंस आएंगे, जैसे कि मैडम ने बताया कि सन और अर्थ के बीच में आदित्य L1 है, हमेशा उनके बीच में रहेगा, तो इन इरप्शंस को आदित्य L1 को पार करके ही आना होगा। सो जब ये आदित्य L1 पे टकराएंगे ये इरप्शंस, तो आदित्य L1 उन इरप्शंस की स्टडी कर सकता है, उन इरप्शंस के अंदर किस टाइप के एनर्जेटिक आयंस हैं, उनका मैग्नेटिक फील्ड कितना है, क्योंकि यही मैग्नेटिक फील्ड डिटरमिन करता है कि अर्थ में क्या जियोमैग्नेटिक डिस्टर्बेंसेस होंगे, अर्थ में कितना इफेक्ट पड़ेगा, अर्थ के अराउंड जो सैटेलाइट्स हैं उनमें क्या इफेक्ट होगा। सो इस तरीके से जो सातों इंस्ट्रूमेंट है वो डिफरेंट एस्पेक्ट्स ऑफ सन को स्टडी करेंगे, सन, इट्स एटमॉस्फेयर एज वेल एज द एंटायर रीजन बिटवीन सन एंड अर्थ, विच इज ऑल्सो नोन एज द स्पेस वेदर, उसको स्टडी करेगा। सो
Okay, you can see visuals of the PSLV, as Ms. Dakshayani rightly said. It's the ISRO's trusted workhorse. It is going to, in a few minutes from now, launch the spacecraft, which will find its final destination at the Lagrange point, and from where it is going to study the sun closely. Ms. Dakshayani, one question that I've been wanting to ask you, when you and Mr. Pant have been explaining to us about the mission details, the objectives, it all sounds quite seamless, quite procedural, but the truth is that all of this is quite complex and it requires years of hard work. As someone who's an expert in the mission area, I would like to ask you this question. When you conceive such complex missions, what is it like? What is the atmosphere like? How do you convince your superiors? How do you formulate ideas? And then how do you actually ensure that it meets the desired outcome? Since you've led successful missions at ISRO, you were part of the Mangalyaan mission as well, I would like you to take this question and explain to us and our viewers, ma'am.
Yeah, it is a really good question. In fact, I have worked for Aditya mission also.
Right.
See, here L1, it is a point. There is no actually a gravitational body is there, so that we can easily formulate the trajectory of the satellite Aditya around L1. Okay, so it took us for like few weeks to understand how to generate the trajectory of this Aditya L1. And what happens when we generate the numbers, we should convince our management, higher ups, that whatever we are doing is correct, and whatever the numbers we are generating, they are the correct numbers. But before convincing them, first we should get convinced ourselves.
Right.
So what we do is, we always see whether any other satellite, like one of the satellite which was in L1, that NASA is it is a satellite, SOHO. It is also around orbiting around L1. So whatever the information is there about SOHO, we have compared with that. That is one level, and we'll always have an analytical way of finding the solution so that whatever we are doing is correct or not. And whatever the experience we have gained so far, so the dynamics modeling, what we are doing about a point which is not a gravitational body, so that has given us a confidence that we are able to do this also correctly, and that knowledge also has definitely helped us to find out how to generate the trajectory around a non-gravitational body. This is how we do. Once we get convinced ourselves, we are definitely able to convince the management. So that is how our design goes. Before my retirement, I was involved in the Aditya dynamics modeling around L1. So it is this way we'll get convinced ourselves, and then we'll make our management to get convinced, because we will be confident enough once we get convinced. Okay.
Right, right. Ma'am, also, if you could tell us about the challenges involved in this mission, since before your retirement you were associated with this project itself. We have now understood the objectives and the findings that it seeks to get in terms of, the various components of the sun. But the fact that there will be challenges, every mission has challenges. What are the challenges that you see that Aditya L1 mission will be having?
Yeah, that the first challenge, whatever I told, how to generate the trajectory of Aditya around a non-gravitational body. That's one thing. And the next thing is, you see, Aditya L1 is placed at a point which is around 1.5 million kilometers from the Earth. So definitely there will be more impact of heat on the subsystems, as well as the whatever the instrument spectrometers, whatever he has told, all the 7 equipments which are there on the satellite to view the sun, okay, sun structure. So definitely a thermal management has to be taken up to do so that our subsystems will not get affected due to the excess heat. It may, the temperature may go around more than 50. I've seen in one of the spacecraft Soho, in one of the paper, they told it has sometimes reached around 58 degrees centigrade also. So that has to be taken into account, and all the thermal insulation, whatever is required, that has to be done to the spacecraft. And another thing is, it is quite far from the Earth. So we have to have an high gain antenna to communicate with the satellite. That anyhow we were having that high gain antenna even in Mars mission also. So actually it is not a problem for us to communicate with the satellite with our deep space antenna, which is situated at Bailalu at Bangalore. Okay. So that is another challenge. And one more challenge is determining its orbit. Once we put it around L1, we have to continuously get the data, nearly some 8 hours data. We have to get from, not only from our station. Data means what is the range of the distance of the Aditya L1 from our ground station,
Right.
and also how the distance is varying. We call it as range rate. That information we get. So not only our station, we will use the other station also, which is almost 180 degree away from our station. Okay. So that data we have to use and determine the orbit. And moreover, the another biggest challenge is the insertion of the satellite around Aditya L1. So you have to compute right from the point where you are injecting for a particular day. We will compute back what should be the parameters we should give to the launch vehicle, so that after all these earth burns, and when we give trans L1 injection velocity, and finally when we reach, how we can insert it around that. So that is also another one of the most important challenge in this Aditya mission.
Right. So there are a couple of challenges, Pratibim, but we're hopeful that
Yeah, definitely.
with the kind of success ISRO has been achieving of late, with the kind of missions and complex missions that we are involved in, we will hopefully be able to taste success in the Aditya L1 mission as well, and achieve
Yes.
the desired outcome that our scientists have foreseen in terms of gaining from this very, very crucial mission.
और ये L1 पॉइंट की बात की जाए तो ये शायद इसलिए भी चुना गया, वहाँ पर जाकर चीज़ें स्थिर हो जाती है, फ्यूल कम खर्च होगा, ईंधन की खपत कम होगी और ज़्यादा समय तक टिककर ज़्यादा ऑब्जर्व कर पाएगा सूर्य की गतिविधियों को। क्या ये बात सही है?
हाँ, कुछ हद तक सही है, पर L1 से भी ज़्यादा स्टेबल पॉइंट है हमारे पास। फॉर एग्जांपल L5 ज़्यादा स्टेबल पॉइंट है, बट जैसे कि मैंने आपको बताया कि L1 इज़ लाइक अ फर्स्ट स्टेप
पास है।
और उसके बाद फिर हम सोच सकते हैं और लैग्रेंजियन पॉइंट पे जाने की, वहाँ पे स्पेसक्राफ्ट को लॉन्च करने की। बट या सो दिस इज़ द फर्स्ट स्टेप, सो लेट्स सी।
जी। एक बात और है, जलवायु परिवर्तन से पूरा विश्व जो है दो चार हो रहा है, उसकी वजह से अलग वेदर जो है वो प्रभावित हो रहा है। तो क्या उस पर भी कुछ काम होगा कि सूर्य पर होने वाली गतिविधियों का क्या असर पड़ता है मौसम पर और जलवायु परिवर्तन में, वो किस तरीके से तो कारगर या प्रभावित सिद्ध हो रहा है?
हाँ, सो देखिए, जैसे कि मैंने आपको बताया कि सन की 11 साल की एक साइकिल होती है। हाँ, तो इसी 11 साल में सन की रेडिएशन भी कम और ज़्यादा होती है, और ये रेडिएशन जो है क्लाइमेट मॉडल्स में इनपुट की जाती है।
जी सर।
उनका इफेक्ट देखने के लिए कि वेदर के कैसे पैटर्न्स चेंज होते हैं सोलर की इरेडियंस चेंज होने से। नाउ 1645 से 1715 के टाइम का जो टाइम पीरियड था, इस ईयर में सन बहुत कम एक्टिव था, तो उसकी रेडिएशन काफ़ी कम रही होगी। किसने मेजर नहीं करी, पर रही होगी, ऐसा हम मानते हैं। एंड इंटरेस्टिंगली वो जो है एक मिनी आइस एज से कोइंसाइड करता था। सो ये अभी भी काफ़ी सारी स्टडीज़ हो रही हैं इस फैक्ट को समझने के लिए कि क्या ये केवल कोइंसिडेंस है और ये सच में एक कोरिलेशन है कि सन का जो इरेडियंस है वो अर्थ के क्लाइमेट को अफेक्ट करता है। तो ये इस पे भी हम स्टडी करेंगे, बिकॉज जो सूट इंस्ट्रूमेंट है वो सन का इरेडियंस मेजर करेगा इन नियर अल्ट्रावायलेट, एंड देन वी विल बी एबल टू सी वेदर दिस irradiance, if it can be input, it can be given as an input in climate models, whether it will affect the Earth's climate or not, or to what extent it is affecting the Earth's climate. क्या ये ऐसा भी कहना ठीक नहीं है सब कुछ सन की वजह से हो रहा है, बिकॉज हमारे लोकल मैन मेड एक्टिविटीज़ भी काफ़ी सारी हैं, बिकॉज पॉल्यूशन है और भी चीज़ें हैं, पर कितना इफेक्ट सन का है, कितना इफेक्ट ये लोकल मैन मेड चीज़ों का है, ये हम क्वांटिफाई कर सकते हैं।
Precisely. So, this is what we seek to achieve from this particular mission, the Aditya L1. The satellite is set to be launched in just a few minutes from now. 11:37 by the clock. 11:50 is the time that ISRO has given. You can see visuals on your screen. Preparations, in fact, all set for the launch, I should say. The countdown is about to begin. The scientists have taken their positions. You can see also the ISRO chairman with the core team of the mission. And in just a few minutes from now, at about 11:50, the launch will take place. Our scientists who are with us on the panel have been explaining to us what are the desired outcomes, the key objectives from this mission. And this is just the beginning. If we taste success, there are other points that we can further go in order to study the sun. And what's interesting about this particular mission is that once it is launched, it will take our satellite closer to the sun, but still the distance traveled will only be about 1% of the distance between the Earth and the sun. So even though we aim to reach closer to the sun, we will still be traveling only the distance of about 1% between the biggest star, the sun, which is the center of our living, and the Earth, which is believed to be the only planet which has life currently.
और विज्ञान से जुड़ी हुई जब भी कोई बड़ी गतिविधि होती है, वो किसी एक देश से जुड़ी तो होती ही है, बल्कि पूरी मानवता के लिए भी होती है। और नासा इसलिए कहीं ना कहीं इस मिशन से भी जुड़ा हुआ है। उसका क्या रोल है, क्या भूमिका है?
हाँ, देखिए, जैसे मैडम ने पहले ही बता दिया कि ऑर्बिट वहाँ तक पहुँचने के लिए, L1 तक पहुँचने के लिए विल बी टेकिंग द इनपुट्स फ्रॉम नासा, क्योंकि एंड ईसा, बिकॉज वो वहाँ तक जा चुके हैं। सो पहली बात तो ये, दिस मिशन इज़ मोस्टली इंडिजीनियस. ऑलमोस्ट ऑल कंपोनेंट हैव बीन कंस्ट्रक्टेड इन हाउस बाय डिफरेंट इंस्टीट्यूशंस. So, but then once the data will be released, then I'm sure that almost all countries, including USA, UK, as well as Europe, they will be interested in using the data, because as I said, this is a very unique mission. We are going to observe very close to the surface of the sun, which has not been achieved before. We will be obtaining the spectra, high quality spectra, using multi-slit spectra, which has not also been done before, which with much success. So these all is an important data set, or important data that I think NASA and ESA would like to look at it. and complement with their own missions, and then come up with a good explanation why different phenomena happen on the sun.
Right.
So yeah.
Okay, Ms. Dakshayani, before we allow you to leave, just one last question about the solar mission. We're all very, very excited because it's our first such space odyssey and aimed at studying the sun. But the question here is, we've had 3 Chandrayaan missions, but the first solar mission, what took so long for ISRO to get closer to the sun, ma'am?
Yeah, actually, we had one astrosat mission in which we were observing all the celestial bodies. For us, the Chandrayaan landing on the moon was one of the more complex process which ISRO wanted to build its own lander and want to land using indigenous technology. Whatever the autonomous landing sequence was there to land successfully, which landed successfully the moon, it was indigenous technology. So ISRO that has proved it. After that, the solar mission we have taken up. Definitely, what he has explained, sun is not a star which we have not understood fully. I think many people say they are only some 98% of the sun only we have understood. So definitely ISRO also thought our various scientific institutions are there, like Indian Institute of Astrophysics, IUCAI, the Intercenter University for Astronomy and Astrophysics, and our URO Satellite Center. There is a group who study about the astronomy and all that. So we have to take up to study the sun, because definitely if we study the sun, it will be helpful to the mankind in terms of, he has already explained, whatever that coronal mass ejection is there, that will alter our, it will lead to disturbance in our communication system, and also it will disturb our weather pattern, and even solar flares and whatever solar wind, that also will have influence on our satellite orbit itself, which normally we model. But in my experience in ISRO, what I have observed is, many a times when high solar flare activity happens, whatever the predicted magnetic activity is there on the earth due to the sun's magnetic that solar flare, and also that solar flux value, whatever is there, what has been predicted, it is almost some 2 to 3 times higher than what we have predicted, the observed one. So that will have an impact on our satellite maintenance, whatever our satellite trajectory is there. It will have an interference with our communication system. It will have a direct effect on our mobile application or TV station. So definitely we have to study the sun. And another thing is whatever equipments we have put, if we study the sun, we can have collaboration with other scientific missions to sun, like SOHO, AS, Wind, so that collectively we can get to know more about the sun, which will help the mankind.
Right, and all our missions in a way are aimed at the larger welfare of mankind. So for example, the Chandrayaan 3, because we landed now on the South Pole, the kind of studies, the kind of experiments that are being conducted are going to not just help the Indian scientists, but the global scientific community. So we hope that with this solar mission also, we will be able to carry out studies and get solar data of a kind which has not been achieved by other agencies so far, and something that we can share with the larger scientific community for greater study of the sun, which we reiterate is the center of our living. But at the same time, it could also in the times to come be one big reason for destruction of mankind. So this is something that if we need to study about, the scientific community needs to know greater detail about the sun, the harbinger of life on earth. And as you can see again, live visuals on your screen, the scientists are all set for the launch. It's 11:45 by the clock, 11:50 is the time, just about 5 minutes for this crucial launch to take place from Sriharikota.
और सबसे बड़ी बात यह है कि इस अभियान से जुड़े हुए वैज्ञानिक तो वहाँ पर मौजूद हैं, आम लोग भी हैं और बड़ी संख्या में स्कूली छात्र और छात्राएं वहाँ पर पहुँचे हैं और बाकायदा इसरो की तरफ से उन छात्र छात्राओं को आमंत्रित किया गया है इस अभियान को देखने के लिए।
And this excitement, Mr. Pant, is palpable. We've been seeing, especially since the launch of Chandrayaan-2, the kind of, excitement and the hope that ISRO will see success with the kind of hard work that the scientists have put. How do you see successes of these missions open up the space sector for the youth, for the private sector? Because this is huge for India, the kind of effort that ISRO is making. And it's also important at the same time that with the kind of ambitious missions that we are now planning, more and more involvement of the private sector and also more and more participation from the youth is important.
Yeah, I think now ISRO is launching like different missions, starting from AstroSat, then Chandrayaan 1, 2, 3, now Aditya, and then there will be the Gaganyaan mission. So that opens up a lot of possibilities for young minds, for those who are doing their undergraduate and graduate studies. So so this is very interesting, as well as now I always felt that there are three pillars for a mission success. First is, of course, the successful launch and reaching there. Second is getting the science out of it, whatever we have expected, whether we should get that science, whether we are getting that or not. And the third one is to spread the word among the community. And you are asking about the third pillar there. So it is very, very important to go back to the society and tell them, okay, this is what we have achieved and this is what is possible and what can be done in future. And this has been started very recently. After, let's say, starting from AstroSat, even before that, and now now I think the young generation is now convinced, of course, and they are motivated by looking at the success of these missions, that in future they can also get involved in such type of missions and then do certain important contribution to the society. This is also important for the private sector, because until now I believe there was not much private participation in these missions, but now once our space agency is opening up to private players, so I think they will also have a huge opportunity, because now we are planning for more and more missions, so they will have more opportunity to create let's say electronics or other components for these missions. So it will be an interesting opportunity for them too. So yeah.
Right, just 2 minutes for the launch to go, so we'll cut across live to the telecast that is coming in from the ISRO headquarters.
T-minus 2 minutes and counting.
अब हम उड़ान से 1 मिनट 50 सेकंड की दूरी पर, यह PSLV की 59वीं उड़ान होगी और इस PSLV एक्सेल संस्करण में यह 25वीं उड़ान है। इसरो के वर्क हॉर्स कहे जाने वाले इस रॉकेट कई ऐतिहासिक मिशन को सफलतापूर्वक संपन्न किया है, जिसमें चंद्रयान 1 और मार्स ऑर्बिटर मिशन उल्लेखनीय हैं। यह प्रमोशन वर्ष 2023 का 7वां मिशन होगा। इस साल की शुरुआत में SSLV के सफल प्रमोशन से शुरुआत कर LVM-3 के 2 प्रमोशन, GSLV Mark II का 1 और PSLV के 2 सफल प्रमोशन हो चुके हैं। यह PSLV का वर्तमान वर्ष में 3रा मिशन है।
All stations stand by for the time mark. T-minus 1 minute and counting. Minus 55 seconds.
All stops are armed.
Minus 50 seconds.
All sequencers armed.
तो हमारे साथ बने रहिए। अब 40 सेकंड पर
Minus 40 seconds.
प्रमोशन किया जाएगा।
HPP open.
Minus 35 seconds. Minus 30 seconds.
Real-time programs activated.
Minus 25 seconds.
PS2 VSPP open.
Minus 20 seconds.
PS on ignition RMS arm.
Minus 15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Plus 5 seconds.
Lift off normal.
P1 tracking. P3 tracking.
Plus 10
Magnificent
seconds.
liftoff of PSLV C-57 with Aditya L1 on board.
Plus 15 seconds.
PSLV C-57 का सफल उत्थापन और इसके साथ
20 seconds.
प्रथम भारतीय सौर अंतरिक्ष यान निकल चुका है सूर्य के
Plus
तेज से
25
विज्ञान को प्रकाश करने।
Air lead strap on ignited.
इसके साथ ही
Plus
एक और
30
कदम
seconds.
है अंतर्ग्रहीय सफर में भारत की उपस्थिति सिद्ध करने का। आप देख रहे हैं PSLV C-57 प्रथम चरण पूरी तरह सामान्य।
The rocket flying forth, following nominal trajectory and developing nominal thrust. The bright fumes against a clear midday sky.
Engine main auto.
A rocket launch is more than just a sight to behold. The roaring sound and the vibrations that we can feel here, adding to this, the thrill are just amazing. Ground lit and air lit strap-ons operating together with the first stage S-139.
Ground lead strap on separated.
जैसा कि निर्धारित है ग्राउंड लेड स्ट्रैप ऑन को सेपरेट कर दिया गया है
Performance normal.
और प्रथम चरण का निष्पादन सामान्य है। इस घटनाक्रम में अगला एयर लेड स्ट्रैप ऑन को यान से पृथक कर दिया जाएगा।
Air lead strap on separated.
जी हाँ, इसकी भी पुष्टि हो गई है। स्ट्रैप ऑन को सफलतापूर्वक पृथक कर दिया गया है।
We are 100 seconds past the launch time. The ground lit and air lit strap-ons have been separated. S-139 motor still thrusting.
S-139 110 सेकंड के प्रज्वलन काल के पश्चात उसे भी पृथक कर दिया गया है।
Plus 2 minutes.
द्वितीय चरण जो कि तरल नोदक पर आधारित चरण है, इसका प्रज्वलन शुरू हो चुका है और वर्तमान में प्रणोद
Second
उत्पन्न
stage
कर रहा है।
performance normal.
The launch vehicle is at an altitude of 73 kilometers. First stage has been separated. Second stage has begun its operation and the closed loop guidance has been initiated. According to the announcement by Range Operations Director, PS2 is developing nominal thrust.
PS2 41 टन के तरल नोदक पर आधारित चरण है। इसमें विकास इंजन द्वारा 800 किलो न्यूटन का प्रणोद उत्पन्न होता है और इसका प्रज्वलन काल लगभग 150 सेकंड का होगा।
Shar and Port Blair tracking stations presently acquiring signals. Flight path closely matching the prediction.
Plus 3 minutes.
वर्तमान में यान क्लोज लूप गाइडेंस के अंतर्गत है।
Second stage performance normal.
यान की ऊंचाई 106 किलोमीटर तथा सापेक्ष गति 3 किलोमीटर प्रति सेकंड।
The velocity addition in PS2 regime is going to be from 2 kilometers per second to 4.9 kilometers per second.
Payload fairing separated.
The payload fairing covering the Aditya L1 spacecraft has been separated. The current altitude of the launch vehicle is 118 kilometers. Relative velocity exceeding 3.8 kilometers per second.
जी हाँ, यान अब घने वातावरण से बाहर जा चुका है, इसलिए ऊष्मा कवच की जरूरत नहीं रह जाती है और इस कारण इसे
Plus
यान
4
से
minutes.
पृथक कर दिया जाता है।
Second stage performance normal.
द्वितीय चरण वर्तमान में प्रणोद उत्पन्न करता हुआ और यान पूरी तरह सामान्य प्रदर्शन करता हुआ अपने अनुमानित पथ की ओर बढ़ रहा है।
Second stage separated. Third stage ignited.
द्वितीय चरण को भी सफलतापूर्वक यान से पृथक कर दिया गया है उसके प्रज्वलन
Third
काल
stage
समाप्त होने
performance
पर।
normal.
और तृतीय चरण जो कि ठोस नोदक पर आधारित चरण है, इसका प्रज्वलन शुरू हो चुका है।
We are close to 5 minutes past the launch time. Presently, the third stage of PSLV is operational, developing nominal thrust.
Plus 5 minutes.
तृतीय चरण में 7.6 टन के ठोस नोदक का प्रयोग होता है और इसका प्रज्वलन काल 117.7 सेकंड का होगा। इस दौरान यह 240 किलोन्यूटन का प्रणोद उत्पन्न करेगा। वर्तमान में यान की ऊंचाई 134 किलोमीटर तथा सापेक्ष गति 5.96 किलोमीटर प्रति सेकंड। जैसा कि हम जानते हैं PSLV सबसे विश्वसनीय रॉकेट रहा है इसरो का, वैसा ही प्रदर्शन करता हुआ एक और मिशन PSLV C57 का।
For the present mission, after PS3 completes its burn duration, a coast phase of 200 seconds will follow, in which the rocket will continue to be steered while there is no development of thrust.
जी हाँ, अभी कुछ ही क्षणों में PS3 का प्रज्वलन काल समाप्त हो चुका है और कोस्टिंग फेज इसके बाद जारी रहेगा।
Vehicle in combined hosting for approximately 200 seconds.
Unique to this mission, the PS4
normal
will start twice at pre-designated times and duration. The multiple start capability of PS4 will be utilized very aptly to achieve the argument of perigee of 346.6 degrees, which is very crucial for this mission. The commencement and duration of PS4 burns enable achieving this orbital parameter. Argument of perigee is the angle that is made by the perigee point from the ascending node at equatorial plane. AOP exceeding 300 degrees is helpful in mission planning to achieve halo orbit around L1 with minimal propellant expenditure.
सभी वैज्ञानिक गहनता से अध्ययन करते हुए इन आंकड़ों का, जो कि ग्राउंड स्टेशन द्वारा प्रसारित किए जा रहे हैं। वर्तमान में PS3, PS4 कंबाइंड कोस्टिंग फेज जारी है। यान की ऊंचाई 170 किलोमीटर तथा सापेक्ष गति 7.32 किलोमीटर प्रति सेकंड है।
Vehicle performance normal.
Plus 9 minutes.
Speaking a few words about the Aditya L1, describing the sun, Indian Vedas have said, Yesha Bhagavan Manirakasha Mandalasya Chakravarti Khechara Chakrasya Deepako Brahmanda Bhandasya Asayayo Charkarti Bharvati Charhati Jagat. This mighty jewel, the light of eastern sky, who generates, operates and destroys the universe, while the energy of sun, after having filtered by the atmosphere, is available for the sustenance of earth. The explosive phenomena in sun and the solar flares are a cause for concern to the spacecraft and human space missions. The vantage point for such observations is a place in between the sun and earth.
Third stage separated.
Now we have a successful separation event of the third stage of PSLV.
It is approximately 900 seconds.
Plus 10 minutes.
जी हाँ, तृतीय चरण को सफलतापूर्वक पृथक कर दिया गया है और अब PS4 कोस्टिंग फेज पर है। इस दौरान कोई भी प्रणोद उत्पन्न नहीं हो रहा है। यान प्राप्त संवेग से आगे बढ़ता हुआ और निर्धारित पथ का अनुकरण करता हुआ जा रहा है।
We are 627 seconds from the launch. For another 600 more seconds or so, we will be getting tracking data from the BIAX ground station.
यह कोस्टिंग फेज लगभग 900 सेकंड का होगा। इस दौरान हम आपको कुछ जानकारी देते हैं। लैग्रेंज पॉइंट से जुड़ी कुछ रोचक तथ्य भी हैं, जैसे कि इस पॉइंट का नाम एक इटालियन फ्रेंच गणितज्ञ जोसेफ लुई लैग्रेंज के सम्मान में रखा गया था। उन्होंने 1972 में इसे अपनी तकनीकी प्रपत्र जनरल 3 बॉडी प्रॉब्लम में वर्णित किया है, लेकिन इससे पहले भी 3 पॉइंट L1, L2 और L3 को खोजने का श्रेय स्विस गणितज्ञ लियोनार्ड आयलर को जाता है। L1 पॉइंट पर नासा ने पहले ही सोलर एंड हेलियोस्फेरिक ऑब्जर्वेटरी सोहो को पहुंचा चुका है और विश्व प्रसिद्ध जेम्स वेब टेलीस्कोप को L2 लैग्रेंज पॉइंट पर स्थापित किया गया है। L1 की पृथ्वी से सूर्य की दिशा में दूरी लगभग 15 लाख किलोमीटर है और इसे हम एस्ट्रोनॉमिकल यूनिट में 0.01 एस्ट्रोनॉमिकल यूनिट कह सकते हैं। यह पृथ्वी से सूरज की दूरी का केवल 1% है।
The vantage point for observing sun is a place in between the sun and earth where direct visibility exists to the sun while continuous communication link exists with the earth. These observations will generate a forewarning about disturbances in near-Earth space environment which could pose danger to the communication systems and spacecrafts. Various thermal and magnetic phenomena on the sun are of extreme nature, which cannot be replicated in labs. The best way is to observe the sun up close. The distance between the Earth and Sun is approximately 150 million kilometers. At the central region of the Sun, known as core, the temperature can reach as high as 15 million degrees Celsius. Power source for the Sun is nuclear fusion of hydrogen atoms that takes place in the core. The visible surface of Sun is relatively cool and has a temperature of about 5,500 degrees Celsius. The Aditya L1 spacecraft is planned to be placed in a halo orbit around the Lagrangian point 1 or L1 of the Sun-Earth system, which is about 1.5 million kilometers from Earth, roughly 1% of the distance to Sun. A halo orbit is a periodic 3-dimensional orbit near the Lagrange point in the 3-body problem of orbital mechanism. The object in this orbit stays in place by the gravity of Earth and Sun. It requires little energy for station keeping. Several probes have been placed in space to observe the Sun by various space agencies. Lagrange's point L1 is a great location for solar explorers such as Aditya L1, as it allows for an unobstructed view of the Sun that is never eclipsed by Earth. At L1, Aditya L1 will join spacecraft such as ESA-NASA's Solar Heliospheric Observatory or SOHO, which has been at L1 since 1996.
लैग्रांज पॉइंट एक ऐसी जगह है अंतरिक्ष में जहां अगर कोई चीज़ पहुंचती है तो वह वहीं बनी रहती है, क्योंकि लैग्रांज पॉइंट पर 2 बड़े द्रव्यमानों का गुरुत्वाकर्षण खिंचाव बराबर हो जाता है और इसमें एक अभिकेंद्रीय बल है कि जो कि पिंड को दोनों द्रव्यमान के साथ बनाए रखता है। ऐसे 5 लैग्रेंजियन पॉइंट्स होते हैं पृथ्वी और सूर्य के बीच। इन पॉइंट्स में अंतरिक्ष यान को भेजकर कम से कम ईंधन की खपत पर या उस स्थान पर अंतरिक्ष प्रयोगों को अध्ययन के लिए बनाए रखा जा सकता है। आदित्य L1 उपग्रह को भी ऐसे ही लैग्रेंज पॉइंट 1 पर स्थापित किया जा रहा है। अंतरिक्ष यान को यहां तक पहुंचने में 125 दिन का समय लगेगा। इस लैग्रेंजियन पॉइंट्स के कुछ फायदे होते हैं, जैसे हम यहाँ आदित्य L1 के बारे में बात कर रहे हैं, तो यह अंतरिक्ष यान लैग्रेंजियन पॉइंट 1 के पास जाएगा और यह ऐसा पॉइंट है जहाँ से सूर्य को बिना किसी ग्रहण या रुकावट के निरंतर देखा जा सकेगा और अध्ययन किया जा सकेगा। दूसरा फायदा यह कि विभिन्न मापन या विश्लेषणों के लिए किसी भी तरह की रुकावट या कमी नहीं आएगी। वायु न होने की वजह से इससे दूर तक स्पष्ट देखा जा सकेगा। लैग्रेंज पॉइंट पर इस वेधशाला को रखने का मुख्य कारण यह भी है कि यहाँ उपग्रह लगभग स्थिर रहेगा और उपग्रह के अभिवृद्धि नियंत्रण के लिए अधिक ईंधन की आवश्यकता नहीं होगी। वर्तमान में PS4 चरण का कोस्टिंग फेज जारी है। अब यान की ऊंचाई 280 किलोमीटर तथा सापेक्ष गति 7.18 किलोमीटर प्रति सेकंड है। अब यह उचित अभिवृद्धि प्राप्त कर पुनः प्रज्वलित किया जाएगा।
Vehicle performance normal.
The Aditya L1 spacecraft carries 7 payloads to observe the protosphere, chromosphere and corona, which is the outermost layer of the Sun. These payloads use electromagnetic, particle and magnetic field detectors. First among the 4 remote sensing payloads is Visible Emission Line Chronograph, VELC, which is a prime payload designed as a reflective coronagraph with a multi-slit spectrograph. This payload is developed jointly by Indian Institute of Astrophysics, Laboratory of Electro-Optical Systems, UR Rao Satellite Center, ISRO Inertial Systems Unit and Space Applications Center. The second payload is Solar Low Energy X-ray Spectrometer or SOLEX, designed to measure the solar soft X-ray flux to study solar flares. This payload is developed by UR Rao Satellite Center. Third payload is the Solar Earth Ultraviolet Imaging Telescope Suite, which is a UV telescope to image the solar disk in the near ultraviolet wavelength range. The payload is developed by Inter-University Center for Astronomy and Astrophysics, Pune, LEOS, URSE and IISU. The fourth payload is High Energy L1 Orbiting X-ray Spectrometer or HELIOS, developed by URSE. Is a hard X-ray spectrometer designed to study solar flares in high energy X-rays. The fifth payload is the one which is meant for in situ observations. This is Aditya Solar Wind Particle Experiment, or otherwise called as ASPEX, which comprises of spectrometers to measure low energy particles and high energy ions. This payload is developed by Physical Research Laboratory. The sixth payload is Plasma Analyzer Package for Aditya, in short PAPA. It is designed to understand the solar winds and its composition and perform mass analysis of solar winds. This payload is developed by Vikram Sarabhai Space Center. The seventh payload is a magnetometer or MAG developed by LEOS, which will measure the low intensity interplanetary magnetic field in space using a pair of magnetic sensors.
जी हाँ, आदित्य L1 उपग्रह में नितभार के बारे में जानते हुए इसमें सुदूर संवेदन नितभार हैं और यथास्थिति प्रेक्षण नितभार लगे हुए हैं। सुदूर संवेदन नितभार में सूर्य का प्रेक्षण करने के लिए VELC कोरोना प्रतिबिंबन और वर्णक्रम मापन के लिए है। सोलर अल्ट्रावायलेट इमेजिंग टेलीस्कोप जो कि संकीर्ण और ब्रॉडबैंड फ्रीक्वेंसी में फोटोस्फीयर और क्रोमोस्फीयर प्रतिबिंबन, यह पैराबैंगनी प्रतिबिंबन टेलीस्कोप है। इसी क्रम में अगला है SOLEX सोलर लो एनर्जी एक्सरे स्पेक्ट्रोमीटर, जो कि सॉफ्ट एक्सरे वर्णक्रम मापी है, जो कि सूर्य के प्रेक्षण के लिए प्रयोग किया जाएगा। इसमें HEL1OX हाई एनर्जी L1 ऑर्बिटिंग एक्सरे स्पेक्ट्रोमीटर है, जो कि हार्ड एक्सरे वर्णक्रम मापी है। इसकी अभिकल्पना सोलर फ्लेयर के अध्ययन के लिए की गई है। यथास्थिति निदभार में आदित्य सोलर विंड पार्टिकल एक्सपेरिमेंट, इसका उद्देश्य है सोलर पवन, सौर पवन में भारी आयंस, प्रोटॉन्स और अल्फा पार्टिकल का विश्लेषण करना। अगला है प्लाज्मा एनालाइजर पैकेज फॉर आदित्य। यह भी सौर पवन में उपस्थित कणों में इलेक्ट्रॉन और भारी आयंस की दिशा के साथ विश्लेषण करने के लिए इसे बनाया गया है। एडवांस ट्राइएक्सियल हाई रेजोल्यूशन डिजिटल मैग्नेटोमीटर, इसे त्रिअक्षीय चुंबकीय क्षेत्र के यथास्थिति मापन करने के लिए बनाया गया है और ऐसे 2 समुच्चय लगे हुए हैं इस उपग्रह में।
Vehicle performance normal.
यान पूरी तरह सामान्य, सभी तंत्र सामान्य रूप से कार्य कर रहे हैं और यान अपनी उद्देश्य कक्षा की ओर बढ़ रहा है। आदित्य L1 के निदभार इसरो व अन्य वैज्ञानिक संस्थानों के साथ मिलकर तैयार किए गए हैं। विजिबल एमिशन लाइन क्रोनोग्राफ VLC इंडियन इंस्टीट्यूट ऑफ एस्ट्रोफिजिक्स बेंगलुरु द्वारा तैयार किया गया है। सोलर अल्ट्रावायलेट इमेजिंग टेलीस्कोप सूट इंटर यूनिवर्सिटी सेंटर फॉर एस्ट्रोनॉमी एंड एस्ट्रोफिजिक्स पुणे द्वारा निर्मित है। सोलेक्स और हेलियोस दोनों ही UR राव सैटेलाइट सेंटर बेंगलुरु द्वारा निर्मित किए गए हैं। ASPX और PAPA स्पेस फिजिक्स लेबोरेटरी VSSC तिरुवनंतपुरम द्वारा निर्मित किए गए हैं। और अंत में मैग्नेटोमीटर लेबोरेटरी फॉर इलेक्ट्रो ऑप्टिक्स सिस्टम्स बेंगलुरु द्वारा निर्मित किया गया है। यह कोस्ट फेज जारी रहने वाला है। आइए इस अंतराल में आपको लिए चलते हैं इस मिशन से जुड़ी चर्चा में, जहां वरिष्ठ वैज्ञानिक हमारे प्रश्नों के उत्तर देंगे और फिर इस चर्चा के बाद हम वापस आएंगे लाइव इवेंट्स में।
As we are in the low visibility region of the flight path, we take you to the discussion room where the key personnel connected with the Aditya L1 will enlighten more on the payloads and details. Over to discussion room.
Welcome viewers. After India has made history with the Chandrayaan-3 moon launch, it has now set its eyes on the sun. These scientific breakthroughs back to back are like feathers on our country's hats. In fact, these celestial bodies are very important and are considered as sacred bodies in multiple global religions. The sun is the central body of our solar system.
आदित्य L1 सफलतापूर्वक अपने उद्देश्य की तरफ लगातार आगे बढ़ रहा है। लगभग 4 चरण वो समाप्त कर चुका है सफलतापूर्वक और सफलता लगभग तय होती हुई आदित्य L1 की, और कुछ ही समय पश्चात ये सफलता पूर्ण हो जाएगी जब L1 अपने उद्देश्य को प्राप्त कर लेगा। आदित्य L1 पॉइंट पर पहुंचने वाला ये भारत का पहला सौर अभियान है और इस अभियान के तहत भारत का ये जो मिशन है बहुत कुछ गतिविधियों को, सौर पर होने वाली गतिविधियों को जानने की कोशिश करेगा। उसका असर हमारी जलवायु पर, हमारी पृथ्वी पर, हमारे मौसम पर क्या कुछ होता है उसको जानने का प्रयास करेगा। लगातार हम लाइव आपको दिखा रहे थे कि किस तरीके से आदित्य L1 अपने उद्देश्य यानी कि L1 पॉइंट की तरफ लगातार बढ़ रहा है। 4 चरण लगभग सफलतापूर्वक पूरे कर चुका है और आगे लगातार बढ़ता जा रहा है और वो समय बहुत जल्द आने वाला है। ये देखिए, ये उस वक्त की तस्वीर है जिस वक्त 11:50 पर आज सुबह आदित्य L1 लॉन्च किया गया था। अपने उद्देश्य को प्राप्त करने के लिए लगातार आगे बढ़ता हुआ 4 चरण लगभग सफलतापूर्वक पूरे कर चुका है आदित्य L1। ग्यारह बजकर 50 पर अब से कुछ पहले जब आदित्य L1 लॉन्च किया गया और 4 चरण सफलतापूर्वक पूरे कर चुका है, अपने उद्देश्य की तरफ लगातार सफलतापूर्वक बढ़ते हुए आदित्य L1।
Absolutely. So 11:50 was the time when India's maiden mission to study the sun lifted off, and ISRO has managed to successfully launch the Aditya L1 on its PSLV rocket, as we were discussing earlier, which is ISRO's trusted workhorse. Now, this means that India's maiden sun mission has embarked on a 125-day voyage now to the Lagrange point, the L1, which is about 1.5 million kilometers from the Earth. What happens in this entire period? What are the kind of experiments and studies that we seek to gain from this mission is something that we will understand in greater detail from 2 more guests who are joining us now virtually. In fact, we will connect with them in just a short while from now. We'll get back to the visuals on the screen that you can see. This is the moment when the liftoff happened from the Satish Dhawan Space Center in Sriharikota. 11:50 was the precise time.
और सबसे बड़ी बात यह है टीना PSLV की ये 59वीं यानी कि 59th उड़ान है और इस साल में 3 उड़ान सफलतापूर्वक वो कर चुका है। ये वो अवसर, वो चित्र जब आज सुबह 11:50 पर आदित्य L1 लॉन्च किया गया। 4 चरण लगभग सफलतापूर्वक पूरे हो चुके हैं और अपने उद्देश्य को पूरा करने के लिए लगातार आगे बढ़ता हुआ आदित्य L1।
So the separation stage will take about 63 minutes, as our guests were telling us. This is, in fact, one of the largest and the longest duration that is going to take place with this mission. We'll understand why is it so with the panel of guests who will be joining us in just a short while from now. But all in all, the liftoff has been successful. It's going to be about a 4-month-long journey to the Lagrange point. As our guests earlier on the panel were explaining to us, this is one stable point from where detailed study of the sun is going to be conducted for a period of at least 4 to 5 years.
From the Aditya L1 mission is which is also ejected out in form of plasma, and that can take about 2 to 4 days to reach the Earth. What we are looking for from the Aditya L1 mission is to see the impact of solar flares as well as coronal mass ejections as they come to the Earth. We have instruments which look at not only in the sun direction, but also in other directions, for example, perpendicular to ecliptic or in the Earth directions. The impact is that we need to see when the sun becomes quite angry, what are the ways in which it is affecting the planet Earth. And L1 point being at point L1, which is just 1% away from the Earth, it is able to provide us a lot of new informations of the plasma and the electromagnetic radiations which is reaching the planet Earth.
Thank you so much, sir. So now we'll move on to Dr. Annapurni Subramaniam. So the science behind this mission is very unique. So what's the impact of this on the Earth and also on the heliosphere?
Yeah, so thank you for having me on this show. To put the thing in context, I'm the director of Indian Institute of Astrophysics, and we have delivered one of the major payloads on this mission. This is the visible emission line coronagraph. So if you actually look at the words used in it, it is visible because it is seeing the sun in the visible wavelength. Emission line, so what is it detecting? It is the emission line of certain elements. Because the corona is hot, the emission which you get is in the terms of it's not absorbing the light which is coming from the sun, but it's already hot, so it is coming down by emitting lines. So we are tracking these lines using what? A coronagraph. Now, what is a coronagraph? This instrument makes a total solar eclipse all the time within the instrument. So you are looking at the sun all the time, 24/7, through using this mission, and this instrument looks at the sun as though it is always in total solar eclipse. Now, why you want to have the eclipse all the time? Because you want to see the corona. Why corona? Because when sun burps, when sun is angry, the corona is what it takes the matter away. Now, what is unique about this instrument? This is going to see the corona as close as possible from the disk of the sun. Now, what is so challenging about it? It is because the sun's corona is 1,000,000 times fainter than the disk of the sun. So you have to not see the disk of the sun, but see only the corona. So this instrument is very difficult to make, challenging, but it is made. Now it's going to the orbit. Now what we plan to study using this instrument is the corona, its dynamics. Through this emission line, you can actually measure the velocity by simple physics called Doppler effect. So you can measure the velocity, you can measure how much matter is moving, and eventually how that matter will come to the Earth and the heliosphere. So it's overall this instrument, along with the others, of course, the other PI will also be explaining about it. So these holistically will give you a lot of information regarding not only the sun, but also the heliosphere. Thank you.
That was very interesting, Doctor. Thank you very much. And now we'll move on to Durgesh Tripathi, Dr. Durgesh Tripathi. You are the PI of the for the payload suit. How is that different from other telescopes like Hubble or James Webb? And what are you going to investigate using this?
Good afternoon. My voice is going to mumble because I'm still in the awe of the launch, and one of the payload is gone there. So essentially, JWST, which is James Webb Telescope, and the Hubble Telescope, they are going to look at the universe, different objects, galaxies, star formation, and other objects you see in the universe. Whereas when we talk about Aditya L1, it is going to look at one particular object, which is our sun. And it's also kept on the other side of the Sun-Earth line at the L1 point, whereas the James Webb Telescope went on the other side of the Earth, which is at the L2 point. Now, the scientific difference, of course, they also observe in ultraviolet, but Aditya, as Professor Anil Bharadwaj and also Professor Annapurni Subramanian alluded to, these are multi-wavelength satellite, and they will be observing all across the electromagnetic spectrum. In particular, SUIT is going to be looking at the ultraviolet radiation in 2,000 to 4,000 angstrom, if that matters to you, emits from the lower and the middle atmosphere of the sun. And what we want to look at that how in general the sun's atmosphere is coupled by looking at the observations at various height, and how actually this radiation is coming and getting absorbed in the Earth's atmosphere, and what kind of effect it can have in the chemistry of ozone and oxygen, for example, and also these explosions which are happening, how much radiation they are creating, and how much effect it might have.
Thank you very much, sir. And now we move on to Dr. Satish Thampi. You are connected with the payload PAPA. Already the plasma particles on the moon are analyzed. How do you analyze plasma particles in the sun? And what is the importance of solar winds, and how does it impact?
Thank you. Thank you for giving opportunity to come into this show. As my colleagues, they mentioned actually about the sun. Today we have the auspicious day where actually we are going to our own star, that is the sun. Just I want to tell to the viewers that actually the sun, which is our hero basically in the solar system. If you look into the mass of the solar system, 99% of the mass of the solar system is occupied by sun. And also this sun is plasma. Now, when we are talking about the heliosphere, actually with this, all our planets are engulfed in that thing. You know, we have been studying in decades, maybe in centuries, we have been studying about the sun. But what we are lacking actually a comprehensive approach, because sun is giving its energy mainly in three forms. The first one is the radiation, actually my colleagues already talked about, which we can do remotely from our ground. But the plasma, basically we are talking about the solar wind, what we call the space plasma, as well as the magnetic field. This can be only studied by in situ. If we study all these radiation, particles and field, then only we will get a full comprehensive understanding of the sun. Now, we are getting the first space-based observatory from the Indian soil, and we are making this opportunity. And of course, I am thankful to ISRO and all my colleagues and my teammates from VSSC and all my scientific colleagues here. This is the opportunity we got actually. We are trying to understand actually all the three things: radiation, particles, and field. Already they mentioned about the radiation. Now Dr. Bibin will be talking about field. Just I want to emphasize on the particles. That's why we named it as PAPA. PAPA means Plasma Analyzer Package for Aditya. This is developed by Space Physics Laboratory in support of Vikram Sarabhai Space Center. And now this instrument has two components. If you look at the solar wind, basically it comprises of 95% protons, then alpha particles roughly around 4 to 5%, then equal number of electrons also. So our PAPA is a comprehensive package measuring both ions and the electrons. Now these electrons, like already our colleagues they mentioned actually the major transition events like coronal mass ejection. That's a huge mass which is coming out of sun. Basically it's a plasma. Basically when we are talking about solar and basically nothing but it's the extension of the corona only. That's the atmosphere. Now these particles actually they only actually modulate the energy and momentum of the planetary atmospheres. See when then sun is quiet, like he is not aggressive, sun is what we are getting the ambient solar wind. So if you look into that thing actually, that one actually gives what we call about the interactions, what we call the normal routine phenomenon which is happening on there. But when there is sun is angry, it gives like in a CME, CAR or these sort of events are happening, that is really going to affect our planets. That's what we call the space weather. Now our intention is to understand first of all actually what these effects, basically the solar wind in the ambient condition as well as during this transition events, how this solar wind behaves, and also how this coronal mass ejections which is passing through different planets, how actually what are the different things like what we call about the microphysics, macrophysics and the mesophysics of that things that we want to understand. So one thing is actually it's a physics subjective to understand because we are getting an ideal point, Lagrangian point, which is in the sun-earth plane, and we will be seeing the events exactly there. Second thing is actually we can definitely monitor the parameters. Like what actually PAPA will measure electrons and ions. We will be getting energy, direction, and angular information. Mass information. So if we know these things related to electrons, electrons we don't want the mass, but for the ions we are getting the mass information. Okay. Coupling all this information, actually what we can do is we can derive the plasma moments. That will be definitely going to the modeling part, actually dynamics part, and that will definitely going to tell about the effect of the space weather effects.
Yes.
So in due course, actually, with the L1, in addition to other L5 missions, we will be able to tell. This is the importance of the plasma missions. Yes. That actually, as you mentioned, actually earlier with the lunar mission we achieved, we tried to understand that thing. Really, it changed this plasma studies, changed the perspective of the moon. Now, Aditya will give more detail about it.
Yes.
Thank you.
Thank you, sir. Thank you so much for that, sir. And now we move on to Dr. Dipankar Banerjee. So, you manage the beautiful solar observatory at Nainital. How do you think the studies of heliophysics will supplement Aditya L1? Can you tell us something about the history of solar observatories in India?
That's right. India has a long tradition of looking at the sun from the ground. In fact, from Kodaikanal Observatory, we have been observing the sun for more than 100 years. And also we have beautiful, solar observatory at Udaipur, in the lakeside, and at Nainital. We are looking at the sun. But there are limitations of looking at the sun from the ground because you can only see the lower atmosphere of the sun. So this was very, very important that we could go to the space. And this is a fantastic opportunity. Originally, more than 10 years back, we were only looking at a small satellite program. And then Professor U.R. Rao suddenly came up with this idea, why are we taking baby steps? We should think big. We should go to much longer distance. And then this opportunity came in, the Lagrangian 1 mission. The entire country, all the scientific institution got very much highly motivated. There are multiple payloads were then proposed. So eventually now we have a Lagrangian 1 observatory class mission. And as you heard from my colleagues that it is a multi-wavelength observatory. So that's very important to have the shorter wavelength coverage from the space. And in addition, the ground-based observations are also important. So a combination of the ground-based telescope and the space-based platform is very, very important. And since you asked about the question about the, how Aditya in the overall heliophysics research within the international scenario, we only have 3 spacecraft around Lagrangian 1 point primarily from NASA and ESA. So I think again, this is a fantastic achievement from India. If you could reach L1 with the full observatory class mission, it will really open a new window altogether. So I think this is a great opportunity and we are all looking forward. And as I mentioned, probably we'll request that, a better ground-based facility. We have already projected a National Large Solar Telescope project from the ground. I think this is now high time. We have a very nice ground-based telescope also to complement the capabilities of Aditya L1.
Thank you very much, sir. Indeed, it's a very great opportunity. And now we move on to Dr. Vipin K. Yadav. So you're in charge of the magnetometer. What is the contribution of magnetometer to Aditya program?
You see, the magnetic field measurements are very crucial in space, and especially at L1 point. What we are going to measure with magnetometer is the interplanetary magnetic field that is coming all the way from Sun and towards the Earth. So typically these values at L1 point are around 5 to 10 nanotesla. But these values increases whenever there is an extreme solar event, such as the coronal mass ejection or say a solar magnetic storms. Now these events are crucial to monitor the near Earth space weather, because these can have an effect on the life on Earth. If you remember Quebec, there was an event when the power lines were snapped a few years ago. That was because of an extreme solar event. So to keep an eye on the surroundings of Earth, we need these measurements. And apart from that, for solar wind observations also, these measurements will be crucial. Thank you.
Thank you very much, sir. So now we move on to Dr. Anuj Nandi. So what is the importance of solar flares and the impact in heliospheres? And how does Aditya L1 contribute to all of this?
Good afternoon, viewers. As my colleagues already pointed out the importance of this mission and the instruments about. So the thing is, as you know, that solar flares are the energetic and explosive energy release in few seconds to minutes time scale, and it is order of 10 to 27 arcs to 10 to 32 arcs. Now the thing is, these solar flares, why it is important, as because the solar flares actually tells the dynamics and activity in the sun. So the thing is, there are two unique instruments built by URAV Satellite Center that is going to cover the solar flares from 1 kV to extremely high energy, around 200 kV. And we know that visible sun is only 6000 degree Kelvin temperature, whereas the outer surface of the sun is million degree Kelvin. So the thing is, why there is disparity? So I think these two instruments, along with the other two instruments, VLC and SUIT, we are going to address this $1 million questions, as well as why there is difference. Thank you.
Thank you very much, sir. And now I'd like to go back to Dr. Anil Bharadwaj. So there are many satellites that are sent to the space by other nations. So what makes Aditya L1 different from these satellites?
Well, that's a very good question, because first of all, let me again tell you that India will be the third, or ISRO will be the third space agency to have a mission at L1 point. And I just mentioned that it is multi-wavelength, multi-instrument, and multi-direction, and it measures particle, field, and radiations. So you don't have such kind of satellites existing at L1 point so far and currently. That makes Aditya L1 absolutely unique, because we are going to measure remotely, in situ, and particles and fields. I was also mentioning about multi-direction, and that is coming from the ASPECTS payload, which stands for Aditya Solar and Particle Experiments. And this is going to measure particles ranging from 100 EVs going to several MeVs, which is essential for us to know, because when the CMEs are happening or the sun is quite angry, the plasma which is coming out from the sun ranges from several EVs to several MeVs. And therefore, we should know in what direction the plasma is coming, and whether the plasma is getting accelerated in between when it comes from sun towards earth. And therefore, there is a multi-direction information which is available from the ASPECTS payload, because it consists of two sensors, SWIS and STEP, essentially giving you in two different energy bands. And therefore, we'll be able to quantify the CME, CIRs, and all the processes which is happening on the sun, which gives out coronal mass ejections. Thank you.
Thank you very much, sir, for your remarks. And now finally, we move on to the principal scientist, Dr. Sankar Subramaniam. So how does the Indian science community seek to capitalize on ISRO's space capabilities, especially these observatory missions like AstroSat and Aditya L1?
Yeah, so now ISRO has established that it has a capability to send observatory class missions anywhere in the interplanetary medium. ISRO also is developing capability for small satellite missions like a nanosat, CubeSat, as well as the small satellite capability. That is something which especially a heliophysics community could utilize it, because we can, at a low cost, we can launch many more such instruments which are essential for heliophysics community here in India. So, and also the bigger mission takes its own life cycle, because it requires technologies to be developed for a bigger missions. So in between these big missions, if we capitalize on these small satellite missions, and that will enhances the science capability of our country to the next level. And as you know, the science and technologies are always synergized. As the technology improves, your science improves. When I started my career in solar physics, I started with a photospheric magnetic field. Now we are in a position where we can do coronal magnetic field with Aditya L1, which was not feasible when I was doing my PhD. So similarly, as we move on and as the technology starts to improve, we would be able to generate much more capable instruments, much more compact instruments, which will enable us to do much more science than what we can currently do. So we look forward to capitalize on ISRO's capabilities, both at the large scale as well as at the small scale instruments, and also its capability for developing new technologies in the near future.
Thank you very much, sir. That was very interesting. And to end this, I have a last question to Dr. Dipankar Banerjee. And it's about what kinds of outreach is possible through this launch to energize the scientific community?
This is a very, very important question, and we are proud to be Indian now after the Chandrayaan success. I think it's just not the students, it's the entire country is excited. And we got this opportunity to now travel towards Sun. So it is very important that the younger generation, comes into the research and also utilizes the data. These scientific missions are for the community, and it has to be the community driven. So some of our scientists, who have been engaged with this mission for decades, we understand what is expected to be, this data. But the younger generation, they need to be trained. And so for that reason, we also have a Aditya support cell at Nainital, and we are going around in the country. We are regularly conducting workshops. So through these workshops and training program, we really want to reach out to other, people who are particularly in the universities or IITs, because they have so far not been directly involved with the Aditya mission. So I think we are really, really going out, and we expect that the youngsters, the next generation will come and utilize this data, because the data is for the community. So unless, we have more users, we will not be able to effectively utilize the data, scientific data which is coming, and the way we can help the community at large. Thank you.
Thank you very much, sir.
I think it is very important for us also to reach out to schools and colleges, because the younger generation should be told about this kind of activities which is happening in the country. Chandrayaan 3 launch has galvanized the whole nation, and everybody is interested to know what all is happening in the science and technology within the country. And therefore, this mission, along with the Chandrayaan 3 mission, that is the Aditya L1 mission and Chandrayaan 3 mission, is going to give us a lot of new information which is going to be very beneficial for the country. Thank you. Thank you very much.
Thank you everybody for participating in this discussion. And now we move on to the control room.
Thank you, Srinidhi. And I thank all the panelists for enlightening us about the high-tech science that Aditya L1 is about to do.
जी हाँ, अभी आपने सुना इसरो के तथा अन्य संस्थानों के वरिष्ठ वैज्ञानिकों ने हमारे बहुत महत्वपूर्ण सवालों के बहुत ही रोचक उत्तर दिए हैं। इस दौरान चतुर्थ चरण के बर्न 1 को कंफर्म किया गया है फिजी टेलीमेट्री स्थित स्टेशन से। इसमें यान में होने वाले त्वरण के बदलाव को मापा जाता है और इससे पता लगाया जाता है कि यान के इंजन में शुरुआत हुई थी या नहीं, और इसकी पुष्टि कर ली गई है। लेकिन अभी भी यान हमारे दृष्टि से बाहर है, हमारे ट्रैकिंग रेंज से बाहर है, लेकिन इसकी यात्रा अभी जारी है। और अब हम स्क्रीन पर देख पा रहे हैं यह पूर्वानुमानित पथ दिखाया जा रहा है यह अनुमानित पथ है। ग्राउंड स्टेशन से पुष्टि होने के पश्चात यहाँ पर इसकी पुष्टि की जाएगी। आज 11:50 पर प्रमोचित हुए PSLV C-57 रॉकेट की यात्रा अभी भी जारी है। प्रथम, द्वितीय तथा तृतीय चरण के सामान्य कार्यकाल के पश्चात इन्हें यान से पृथक कर दिया गया था और फिर
टर्मिनल acquires telemetry signal.
जी हाँ, इसकी पुष्टि हो गई है। शिपबोर्न टर्मिनल से हमारे यान को ट्रैक कर लिया गया है।
At present, ground trace and FPD are updated based on real-time data.
अब हमारे ग्राफ को वास्तविक समय से दिखाया जा रहा है। यह वास्तविक डेटा है जो अब हम देख पा रहे हैं।
Welcome back to the live coverage of PSLV C-57 Aditya L1 mission. The launch took place at 11:50 hours Indian Standard Time from the second launch pad at Satish Dhawan Space Center, Shar, Sriharikota. The first, second and third stage of the launch vehicle have performed normally, and the launch vehicle was in the no visibility range for the ground tracking stations. Shipborne terminal in Pacific Ocean has started to acquire signal 51 minutes into the flight.
अब कुछ ही क्षणों में हम चतुर्थ चरण के पुनः प्रज्वलन को देखेंगे।
In the past 26 minutes or so, the ground trace for the flight was being updated by extrapolation.
Fourth stage engine started for band 2.
यहाँ अभी रेंज ऑपरेशन डायरेक्टर ने इसकी पुष्टि की। चतुर्थ चरण का प्रज्वलन शुरू हो चुका है। यह पुनः प्रज्वलन है PS4 का कोस्टिंग फेज के पश्चात। यह वास्तविक समय पे हमें यहाँ आंकड़े उपलब्ध हो रहे हैं क्रूज स्टेशन से।
Very happy piece of news here.
Normal.
Range Operations Director has confirmed the second burn commencement for the PS4 stage. Around 14 more minutes to go for the spacecraft injection.
जी हाँ, अभी भी लगभग 14 मिनट बाकी हैं हमारे अंतरिक्ष यान आदित्य L1 को अंतक्षेपण के लिए। आपकी जानकारी के लिए बता दें कि इस कालावधि जब अंतरिक्ष यान या हमारा यान हमारी दृष्टि से दूर हो जाता है, इस कालावधि में ग्राउंड स्टेशन की दृष्टि से बाहर जा चुका होता है और यान के ऑन बोर्ड कंप्यूटर पर टेलीमेट्री स्टोरेज पर यान के महत्वपूर्ण आंकड़े सेव किए जाते हैं। जब यह हमारे तय ग्राउंड स्टेशन की रेंज में आते हैं तब इन आंकड़ों का प्रसारण होता है और वहां से इनकी पुष्टि की जाती है कि यान इस दौरान किन गतिविधियों से गुजरा।
Fourth stage performance normal.
The fourth stage performing normally. The second burn is expected to last for 472 seconds.
यह चतुर्थ चरण है PSLV XL रॉकेट का। इसमें 2.5 टन के नोदक का इस्तेमाल हो रहा है। यह तरल नोदक हैं। इसमें 2 इंजन लगे होते हैं, हर एक 7.33 किलो न्यूटन का प्रणोद उत्पन्न करता है। इस तरह कुल प्रणोद 14.6 किलो न्यूटन का होता है।
Plus 55 minutes.
इस प्रज्वलन काल में इसे 472 सेकंड तक प्रज्वलित रखा जाएगा। वरिष्ठ गणमान्य व्यक्ति यहाँ उपस्थित हैं।
We are close to 55 minutes 30 seconds past the launch. PS4 stage.
So as the separation procedure is underway,
Going into
ISRO
the
is still
second time.
telecasting live visuals of the entire procedure, expected to last about 63 minutes. We're being joined by Mr. Prakash Rao, former Director, Space Infrastructure Program Office, ISRO Headquarters. He's joining us via Zoom from Bengaluru. Mr. Rao, pleasure to have you again on Sansad TV. We've been watching the visuals while the liftoff has happened, and we are hearing from scientists that the fourth stage is also performing normally. What we understand is this is one of the longest PSLV missions ever undertaken. So to begin with, tell us now, viewers, about the long time that is being taken for separation, sir.
Yeah, as Mrs. Dakshayani has explained, because we have to reach a particular argument of perigee. So for that purpose, what we have to do is, we have to coast. Now actually engines will not be firing, the rocket engines, but it will be coasting by itself so that the energy is conserved. But till you reach a point which is favorable for subsequent operations, because we, as you know, we have got 127 days of operations. So from the overall mission efficiency point of view, we have to reach a point where it will be very efficient process. So towards that, to achieve the required argument of perigee, this is taking a longer time than what you normally are used to seeing in the PSLV. So that is the reason why it is coasting for a long time, and we will take this time. Yeah.
और हम बता दें कि डॉक्टर पी श्री कुमार, फॉर्मर डायरेक्टर स्पेस साइंस प्रोग्राम ऑफिस इसरो, भी हमारे साथ वर्चुअली जुड़ गए हैं। आपका बहुत बहुत स्वागत है। अभी जो जानकारी मिल रही है इसरो के केंद्र से, 4 चरण सफलतापूर्वक पूरे हो चुके हैं। इन स्टेजेस को किस तौर पर देखते हैं डॉक्टर पी श्री कुमार जी?
Hello, could you repeat that last question? I couldn't hear it. Hello.
डॉक्टर पी श्री कुमार जी, हम देख रहे हैं कि जो रिपोर्ट्स आ रही हैं, 4 चरण समाप्त हो चुके हैं, सफलतापूर्वक कंप्लीट हो चुके हैं। अब इन चरणों को किस तौर पर देखते हैं और क्या कुछ अभी बाकी है, अगर बात करें आदित्य L1 की?
Yeah. So with these initial stages of the PSLV operations, the spacecraft actually is on its way to the very unique location that is the L1 Lagrange point 1. It is very important for solar science because of the fact that it allows you to study the sun nearly continuously from over the time when Earth moves around the sun. The spacecraft, sun, and the Earth are in one line, and that is a very unique place to study the many phenomena associated with the sun. So as we are all looking forward to these exciting results from Aditya L1.
Dr. Sri Kumar, just a while ago, we heard scientists from the ISRO headquarters talk about the various payloads, the instruments that are, going along with Aditya L1, the kind of experiments and studies they're expected to conduct. But as someone, who's a specialist in space instrumentation, help us and our viewers understand the complexities that are involved with how these instruments function. How do you ensure that these instruments, once up there, also continue to perform well and continue to send in data that is, credible and authentic?
Yeah. So there are many challenges in a mission of this type. One, of course, is we're trying to push the technology and to its limit by trying to study the sun's corona very, very close to the sun's disk. So the disk of a sun is about 1 million times brighter than the corona. So there's a clever design in the coronagraph which allows us to cut out the solar disk has been put in, and that demands very careful pointing of the spacecraft to the sun. So that stability of pointing is very critical, and ISRO has done tremendous work in actually ensuring that stability is maintained. When the mirrors are made, it requires a surface finish that is of very high quality. We've done a fairly good mirror test of that system would actually happen in space when you actually open the doors and you look at the sun, look at the level of scattering that you'd expect, and we have to make sure that's within the calculated and predicted levels. So these are all challenging elements of it. Third, of course, is the fact that together as an observatory, when all the experiments are working together, you have to bring the information from all these different instruments together to really do the core science that we try to do. Whether it is actually trying to ask the question of what heats the corona, or what is the nature of the solar wind, and how you can contribute to space weather predictions. Combined analysis and interpretation of data from the 7 instruments is very, very critical. So these are challenging things, and I'm sure the team will do very well.
Right. So despite the challenges, it opens up new opportunities, because now it makes ISRO only the 3rd agency in the world after NASA and ESA to actually reach the Lagrange point and study the sun closely. We're hopeful that the entire voyage will be as seamless as the scientists expect it to be, and conduct experiments and studies as the desired outcome is. Mr. Prakash Rao, you've been associated in the area of quality assurance. Since we're talking about the challenges, help us also understand about the procedure, the challenges of making spacecrafts like these. What are the various subsystems that work within a spacecraft?
टीना, आई थिंक पहले जो मुश्किल है वो ये है कि स्पेस सिस्टम्स जो भी काम करना है स्पेस में बिना कुछ अटेंडेंस मेंटेनेंस कुछ नहीं रहता है.
Right.
So कभी-कभी कुछ satellites have to work for 15 साल, and even this satellite though designed for 5 years, it can as well live for 10 to 15 years kind of life it can give. So ये 15 साल तक ये सिस्टम कैसा काम करेगा बिना कुछ मेंटेनेंस. So उसके लिए बहुत कुछ मेहनत करना पड़ेगा कि ग्राउंड के ऊपर कि we have to, and another difficulty is it's a multidisciplinary product. सब कुछ disciplines जो भी engineering में है or even in the science, all those roles play a role, and we are making one product over so many years, 8 to 10 years is taken to make one product. So how do you ensure that the culture of quality, all this is maintained throughout? That is another important challenge, and all this has to be done within the constraint. Because as you can see, the launch vehicle has got only certain volume, certain weight it can lift. So every system has to be made within that. So that's what makes the whole system challenging. And as far as the subsystems of spacecraft go, see, we need a structure basically which accommodates all the subsystems, both the systems which need to support the payloads. We call it as mainframe or bus systems. So all of the systems have to be accommodated, and all the scientific instruments, whatever 7 you have seen, have to be accommodated on the spacecraft in a particular direction so that their cameras will be facing in the required region of interest. And there will be very good alignment requirements, sometimes going to the level of arc seconds. So that is a very challenging thing because it has to withstand the launch vibration. The spacecraft as it goes, the launch time, it will face a lot of vibration. So afterwards also the stability and the pointing has to be maintained. So for that also the structure plays a major role, and it has to withstand all the launch loads. So once all the systems are in place, there are control systems, there are communication systems, okay, and mechanisms are there where so many, like a mirror, Mr. Shivkumar was telling, some lid may have to close, open. In conventional spacecraft, you see solar panels deploying, all those things. So there are a lot of mechanisms, and you need to go from, now PSLV injects in some smaller 235 by 14,000 and odd kilometers orbit. From there, you have to reach 15 million kilometer. For that, propulsion is required. So all those systems have to be there, and thermal system, which has to maintain
and we have a confirmation of Aditya L1 separation. The mission has been accomplished.
और हम बता दें कि जिस तरीके से चित्र आ रहे हैं और वहां पर एक दूसरे को बधाई दी जा रही है वैज्ञानिकों के द्वारा, ये पूरा अभियान अभी तक का सफल रहा है.
L1 को पूर्ण परिशुद्धता
You heard the announcement that the mission has been accomplished. So this makes India, and in fact something that we should be extremely proud of, that after the success of Chandrayaan 3, India is now ISRO is only now the 3rd agency to be aiming to reach at Lagrange point 1, the L1 point, and once it reaches there, after a 125-day period, studies and experiments will continue to study the sun in greater detail. Sun, which is the center of our living. You can see the ISRO chairman congratulating Dr. Jitendra Kumar, the Union Minister. And now the statement.
Congratulations. The Aditya L1 spacecraft has been injected in an elliptical orbit of 235 by 19,500 kilometers, which is intended very precisely by the PSLV, very unique mission mode here, with the upper stage of the PSLV taking 2 burn sequence of Aditya L1 to put it in the right orbit. Now, from now, the Aditya L1 will take its journey after some Earth maneuvers. It will start its journey to the L1 point, very long journey of almost 125 days. So let us wish all the very best to Aditya spacecraft for its long journey and being put around the halo orbit of L1. So with me, the mission executives are there. Mr. Biju, the mission director, and Nigar Shahji, the director of the satellite project. So let them join me. Our Honorable Minister of State for Science, Technology and Space is here, Dr. Jitendra Singh, so I request him to speak a few words.
You have to be there. Congratulations, India. Congratulations, ISRO. And while the whole world watched this with bated breath, it is indeed a sunshine moment for India. Thank you, Honorable Prime Minister Narendra Modi ji, for making this happen by opening up new vistas for India's space sector and telling us that sky is not the limit. Thanks also, Honorable PM, for giving us the confidence, the courage and the conviction to reach out to the stars and to discover the mysteries of universe beyond. And thanks also for making us realize the enormous potential of our space fraternity. Ladies and gentlemen, Indian scientists had been working, toiling day and night for years and years together, but now comes the moment of vindication, the moment of redeeming the pledge to the nation. And coming close on the heels of successful Chandrayaan-3 landing, the successful launch of Aditya L1 is also a testimony to the whole of science and a whole of nation approach which we have sought to adopt in our work culture. While ISRO is credited in executing this mission, the science institutes across the country have come forward to contribute in one form or the other, in small measure or big, to this mission. To name a few, the Indian Institute of Astrophysics, Bengaluru, the National Aerospace Laboratories, the Tata Institute of Fundamental Research, Mumbai, the Nijri NGRI, Nagpur, the IIT Kharagpur, IIT Madras, IIT Delhi, IIT Mumbai, and the list is too long. But that, having said that, gives me the confidence to say that this day, the 2nd of September 2023, is a day of reckoning when we move on into the next 25 years of Amrit Kal, and Mother India pledges with the collective will and collective effort of our 140 crore children to reach and occupy the place of pride on the world pedestal. Congratulations once again, Chairman Somanath, the entire ISRO team, and the entire countrymen.
Thank you. May I request the Project Director of Aditya L1, Nigar Shahji, to say a few words.
Good afternoon. It's a dream come true for Team Aditya L1, and I'm extremely happy that Aditya L1 is injected in the intended orbit flawlessly by PSLV as always. And Aditya L1 solar panels are deployed, and the spacecraft will be normal. And Aditya L1 has started its 125 days of long journey towards L1. We have our Earth burns to rise the orbit, and followed by the trans L1 injection, and finally insertion into the halo orbit in the Sun Earth Lagrange point L1. Once the Aditya is commissioned, it will be an asset to the heliophysics of the country and even to the global scientific fraternity. And I take this opportunity to thank Chairman ISRO, Director URSC, former Director URSC, and all the center directors for their support and guidance for making this mission possible. And my thanks are due to my project team and all the project executives across the center, payload teams, especially the teams from the IAA and IUCA, for the relentless effort in building the payload as well as the spacecraft. And my special thanks to the expert committee who have been guiding all through the entire project life cycle. And I thank all the industrial partners and the entire URSC team for their invaluable contribution. And I feel really honored and privileged to be part of this mission. And at this juncture, I would like to remember Professor U.R. Rao, who sowed the seed for this mission, and looking forward for a successful halo orbit insertion and further great science output from the Aditya L1 mission. Thank you all.
Sri Biju, the mission director and the project director of PSLV.
Good afternoon to all. My big salute to all of you for achieving this wonderful mission of Aditya. We have injected Aditya in its intermediate orbit. PSLV in its 59th mission has successfully accomplished injecting Aditya L1 in its intermediate orbit. It's all because of the dedicated effort of all of you. The challenging requirements given by satellite team was indeed very it was very challenging to meet the orbital requirements. We have gone for a new mission design strategy. We have gone through numerous simulations to validate this, and that is the proof that you are having now. I take this opportunity to thank each and every one of you for achieving this wonderful mission. I take this opportunity to thank all my review forums, chairman and members of all review forums, and our industry partners for giving high reliable systems for PSLV, and all our family members. With this, our capability of PSLV has increased manifold to venture into new missions, to new and challenging missions. I take this opportunity to thank my project team led by our Sri M.J. Lal as well as Damodaran, Vehicle Director and Associate Vehicle Director, in leading the entire campaign. I wish our satellite team an excellent time ahead for completing all the operations and completing all scientific objectives they have envisaged. Thank you all. Thank you very much.
Thank you everybody for spending your time watching this mission and also supporting us and congratulating us, and we joined the entire country. We are very proud of the fact that we could do this mission, Aditya L1 mission, just following the Chandrayaan 3 activities, and all of you are aware that the lander and the rover are still functioning, and our team is with the scientific instruments doing a lot of work now. And the good news is that the rover has moved almost 100 meters from the lander, and we are going to start the process of making both of them sleep in the coming 1 or 2 days, because it has to withstand the night. So until we hear about them later, so I would like to say big thanks to each one of you for the support and encouragement and blessings that you are giving to us for continuing the work of building the very strong space infrastructure and capability for India, and which will be becoming one of the strong pillars of science and technology for this nation. And thank you so much for the contributions once again, and wish you all the best for meeting you for next mission from Satish Dhawan Space Center. Thank you. Starting now.
So there you heard the chairman of ISRO congratulating the team of Aditya L1 mission. Today, indeed, is a sunshine day for India, Pratibim, because 2nd of September will be a day of reckoning for all Indians. This is the day when ISRO becomes only the third agency in the world to be heading towards the Lagrange point to study the sun. Only 2 agencies so far, NASA and ESA, have achieved this feat. It's a long journey, as you heard the ISRO chairman say, 125-day voyage to reach the Lagrange point. But so far, the successful launch of Aditya L1 mission has been achieved, and we're hopeful that in the 125 days, the desired outcomes will also be achieved.
जी हाँ, और सबसे बड़ी बात यह है कि 10 दिनों के भीतर 2 अंतरिक्ष अभियान सफलतापूर्वक हम लोगों ने किए हैं और अंतरिक्ष की शक्ति के रूप में भारत लगातार उभर कर सामने आ रहा है और ये शक्ति ही भारत को अगले 25 वर्षों में विकसित राष्ट्र के तौर पर स्थापित भी करेगी। टीना।
Absolutely. So as our panelists earlier were pointing out, it is carrying 7 payloads, each of them having a different role and function to perform. Lots to study about the sun, which is the harbinger of life on Earth. It still remains a mysterious object. Although we are traveling closer to the sun, let me remind our viewers, the distance being covered is just about 1% of the distance between sun and the Earth. The L1 point is a stable point from where our satellite will be able to view the sun 24 hours, and this will help us carry out experiments, get images, and which will be something which will be very helpful not just for ISRO but also for the global scientific community at large.
जी हाँ, भारत के पहले सौर मिशन आदित्य L1 के सफल प्रक्षेपण के लिए पीएम मोदी ने इसरो को बधाई दी है। उन्होंने एक्स पर लिखा, संपूर्ण मानवता के कल्याण के लिए ब्रह्मांड की बेहतर समझ विकसित करने के लिए हमारे अथक वैज्ञानिक प्रयास जारी रहेंगे।
So India's missions, space missions to be precise, Pratibim, are aimed at the welfare of humanity at large. As our Prime Minister keeps reiterating the concept of Vasudev Kutumbakam, our space journey and our space achievements are also dedicated to the larger welfare of humankind. So as our Chandrayaan-3 mission landed on the south pole of the mission, getting experiments, conducting experiments there and getting data which has not been gotten up so far. The good thing here is that if we become successful in this Aditya L1 mission, if we reach the Lagrange point, there will be newer opportunities for the scientific community to study about the sun, which is our natural star.
और सौर मंडल के बहुत सारे रहस्य ऐसे हैं जिनसे पर्दा अभी तक नहीं उठा है। माना जा सकता है ये शायद भारत के ही जो है संदर्भ में ये सफलता लिखी और आदित्य L1 जैसे ही अपने केंद्र में स्थापित होगा, बहुत सारे तमाम रहस्य हैं, उनसे पर्दा उठाने में हम कामयाब हो पाएंगे। और जैसा कि प्रधानमंत्री का जिक्र लगातार वहाँ पर किया गया, जब सफलतापूर्वक ये लॉन्च स्थापित हो गया है उसके बाद, और प्रधानमंत्री ने सबसे पहले बधाई दी इसरो के वैज्ञानिकों को और पूरी मानवता के लिए इस अभियान को महत्वपूर्ण बताया। और जैसा कि टीना ने कहा, जो हम एक टैगलाइन है, जो हमारे जीवन जीने की हमारी एक पद्धति है वसुधैव कुटुंबकम की, और वसुधैव कुटुंबकम G20 हमारा एक बहुत बड़ा जो आयोजन होने जा रहा है उसकी टैगलाइन भी है। और ऐसे में हमारे 2 अंतरिक्ष अभियानों का सफल रहना कहीं ना कहीं उस टैगलाइन को स्थापित करता हुआ भी nazar aata hai.
Absolutely, and what's also true, Pratibim, is the fact that the Prime Minister reiterating time and again that science, and particularly space science, is something that India has been doing well, particularly in. It's time for the private sector to come in big. It's something that should inspire the youth of the country, which happens to be India's biggest asset. And this is what is going to lead India on its development journey. So that having been said, we'll have to wind up the program for now. That's all from me and Pratibim. Thank you very much, viewers, for your time.
और इस अभियान के लिए पूरे देश को ढेर सारी शुभकामनाएं और बधाई। नमस्कार।